So the slide NCERT based questions, today's target. Okay, let me check it out. Hey kids, I think I'm audible and visible to all of you. Am I live, kids? If yes, I want to know from your side. I want to see green signal from each and everyone's side. Kids, do let me know that am I audible and visible to all of you? Punctuality means a lot. Yes. Whenever you want to see that Baba's punctuality, then definitely I'm always punctual. Very, very good evening, Kumuda, Hames. Good evening, good evening, good evening. Now, my dear students, let me check it out that everything is perfect or not. Yeah. So, kids, how is the Josh? If it's high, I want to see it should get reflected in the chat section. Chat should move out very speedily. I want to see that thing from your side, kids. Yes, kids. Yeah, thank you, Mandy. Thank you, Kumudha. Thank you to each and everyone. Kids, today this hydrocarbon, I will tell you about the reactions, concept, physical, chemical properties, and then my target is mainly to solve questions. Whatever the questions they are going to be asked in your coming NEET examination, whatever the type of questions, whether tough or easy, that should be my main aim to deliver such type of handwritten questions totally made from NCERT, but yes, they are most expected for this year. So I will not keep this session too long. My policy is to make it shorter and to complete it easily and within the time. So just you have to focus on one thing, that what are the questions we are going to deal with, you should solve it accurately, because accuracy is more important than speed. Once the accuracy is there, speed will be there. So whatever the questions you are going to deal with, but before that, whatever the concept you are going to grasp, because once if you don't know the concept, if you are not having good command on the concepts, you won't be able to solve the questions. To solve questions easily, your concept should be there in the hippocampus. Solving questions accuracy just gets reflected that how much concept you're going to keep in your hippocampus, in your memory. So if you are ready for that, then only it will be maximum of 5 to 6 hours. Today's session I will not keep too lengthy, kids, because I know that kids are having so many things to do with. So I would like to make it, to give it concise way, in the concise way. That's my target, right? So I can see the Josh is very high. Kids are so awesome. So ready to get it. Just let me switch on one more light so that my face should start glowing, or I'm completely perfectly you can see me. If it's perfectly you can see me, then I'm not going to switch on any other light. Just to let me know in the chat section. And kids, likes are so less. Why kids, likes are so less? I can't understand, kids. You're not liking your Baba HSP, everyone. Just to let me know why likes are less than the live viewers. Now, my dear friends, before I start, I would like to share this thing. One of the most important thing I would like to share, kids. Then only I'm going to start the class, right? Now see, only 5 months till NEET exam. Start your serious preparation at just rupees 4,799. Now, if you apply code Baba HSP, no Baba HSP, it's HSP 10, you will get huge discount. To get discount, apply this code. Okay, code is HSP 10. Now, those who don't know who is Baba HSP, I will tell you in brief who is your Baba HSP. HSP, I will let you know, kids, right? But before I start the class, let's go and let's see what's next. This is the team. You can see the best teachers. All teachers are the best teachers in this universe for your NEET selection. Let me tell you, this class is equally good for NEET, for IIT, and even if you're preparing for your class 10th boards. 10th board students can also gain lot of knowledge from this class, so it is equally good. Now you can see it's just for rupees 2,799. Now my dear students, before I move further, by getting enrolled in this, whatever the batches, you will get free practice questions. So link is given in the description, right kids? So why my face is not visible over there, kids? Am I audible and visible? I cannot see. Let me refresh. I think something has gone. Yeah. Oh, yeah. Now it's okay. Now kids, who is your HSP? Where the slide has gone? Hey, where are you, HSP? That slide is missing. Let me check it out. Where is that slide? Who is HSP? See kids, how much hard work I have done. Before I move ahead, let me show you. I've taken out screenshots from the NCERT. I will show you all these screenshots, yes, as the slides, and then I will tell you how the questions will get framed out. Already I have written handwritten questions over there. Kids, smile that you are getting this class from Baba HSPC. Number of slides are there. I will deal with all these slides. I will go with all these slides, kids. Now see, handwritten questions are there. You can see number of things are there handwritten, but I don't know where the slide of Baba HSP has gone. Leave it, no problem. But see, number of questions you are going to deal with, how much hard work I have done for you. Let me show you all the slides, all the questions. See, handwritten questions, everything I have prepared for you, kids. See the questions handwritten, most expected questions. See. Just show green hearts for your Baba HSP, how much hard work he has done for you, kids. How much hard work. See, all new questions I'm making for the last 3 to 4 days. See, all new questions. Just see all new questions. I want to see green hearts in the chat section for your Baba HSP for this hard work. Then only I'm going to start the class. Yes, everyone, speedily. Everyone, all Phoenix 2.0, Phoenix 3.0, Nexus, and all Tube students, all YouTube live viewers, kids. Yes, if you are ready, fire in the chat section. Fire. Now if you're ready. One kid is asking, increase the volume. In the starting only I have asked that, am I perfectly audible and visible? Kid said yes. Then why you are asking for increase the volume? I can't understand. Okay, now, are you ready? Hey everyone, are you ready? First, keep the concept in your brain and then do all questions. That's it. Nothing else we are going to deal with. Hey everyone, say, I will deal with the concept. I will keep the concept in my brain, and then I will solve all the questions. I will try to keep all the concepts in my brain. Then I will solve all the questions. That is the target for the day. Today, everyone, 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 everyone. Thank you, Kumada. Thank you. Now, ready? Let's it go. Here it starts the preparation of alkene. So what I'm going to deal with, let me tell you. Today, the hydrocarbon, today's hydrocarbon. In hydrocarbons, what we will deal with, so we will deal with alkane. We will deal with alkane, alkene, alkyne, and benzene and its ESR reaction. This is our target for today. Their preparation, their chemical reactions, a lot of questions, expected questions. That's our target for today. Alkane, alkene, alkyne, benzene, ESR, and the based questions. Their preparation, chemical reactions, and expected new NCERT based questions, NCERT based questions, right? Simple this is simple, simply good. This is our target for today. So I'm going to start with alkane. I'm going to start with alkane. As we know very well that alkanes, CnH2n plus 2, saturated hydrocarbons, saturated hydrocarbons. How scientists, they don't know that they are saturated hydrocarbons? They have done one test that they do not decolorize bromine water. They do not decolorize bromine water. Everyone say with me. Everyone say with me. They do not decolorize bromine water. Do not decolorize bromine water. And they are non-polar. Smaller alkanes are non-polar and higher alkanes are slightly polar. That means they will not show generally the most of the chemical reactions. They will show only few chemical reactions. That means alkanes are the least reactive. Can I say alkanes are the least reactive? Everyone, can I say are non-polar, are non-polar or slightly polar, slightly polar. So therefore we will say are least reactive, are least reactive. That means, my dear students, if examiner is going to frame out the question, he will frame out the question from the preparation of alkane. Very few questions are going to come in examination from the chemical reactions of alkane. Maximum questions will be from the preparation of alkane. Say yes, you are getting what I'm saying. Everyone, once you are getting what I'm saying, write down yes. Kids, I want to see that you are in front of me. I want to get that feeling that I'm in front of you. I can feel you. I can hear you. I want to see you. How I can see? Only the camera is in front of me. whatever I'm asking, you can just get the sense of that. Yes, write down, yes, everyone, I want that feelings. Kids, then only I can give you the best, whatever I want to give you. So, now, preparation is highly important. Kids, preparation is highly important. So, let's see the preparation. Everyone ready with the preparation? And in the preparation, we will deal with which one is the first one. In the preparation, the most important one is soda-lime reaction. Have you heard the name soda-lime reaction? My dear students, this reaction is given in class 10th also. You are studying this reaction from the class 10th. If you have not studied, that's a crime. You should know this reaction. Soda-lime reaction is also known as lab method preparation of alkane. Lab method preparation of alkane. Preparation of alkane. Now, we always write down this reaction, that how this reaction proceed, because we are higher level teacher, but examiner can give one question. This alkane is prepared by downward displacement of water, upward displacement of ammonia, upward displacement of water, downward displacement of HCl. So what should be the correct answer? Then definitely the answer will be alkanes are prepared by, yes, I want to see answer from your side. Alkanes are prepared by, alkanes are prepared by, yes, I want to see answer from your side, by downward displacement of water. Now, if examiner is giving this question is the form of assertion and reasoning, then what should be your answer? Because alkanes are slightly soluble in water and lighter than water. The reason will be, definitely your reason will be, kids, alkanes are because alkanes are slightly soluble in water and lighter than water. Lighter than water. Now see, kids, have I ever taught you like this? Always, whenever a teacher is teaching, he or she will teach like that. Wow, how the alkane is being prepared. Have you seen any teachers teaching you in this way, that how they are being prepared? This is something new, and definitely the examiner will ask this thing. Now, generally what we were teaching, we are teaching like this, that RCOONA, Rexona, RCOONA plus soda lime, NaOH, in the presence of CaO gets RH plus Na2CO3. This we know very well. But whatever the carbon it is having, number of carbons, if I say X carbons it is holding, so your alkane will be X minus 1 carbons. X minus 1 carbon or carbons, right, kids? That means it is used for shortening of the chain. Everyone say it is used for shortening of the chain. This reaction is used for shortening of the chain. This method is used for shortening of parent chain or any chain, shortening of chain by one carbon, by one carbon. Remember that, by one carbon, by one carbon. Now, one question arises that what's the use of quicklime? Why they are using this quicklime? Anyone? If you know the answer, whenever I'm writing something over here, do let me know in the chat section. This is quicklime. What is the use of this quicklime? And this is caustic soda. Caustic soda. Now, if there is anyone, they can ask minute questions where your teacher is not focusing, where you people are not focusing. They will hit over there that this is deliquescent in nature. Remember that this is deliquescent in nature. Deliquescent. Everyone said deliquescent. Deliquescent means which absorbs moisture from the atmosphere and gets dissolved in it. But your quicklime is hygroscopic. What I said? Hygroscopic. Hygroscopic. It is being hygroscopic. This will also absorb moisture from the atmosphere but does not become wet. Both of these two absorbs moisture from the atmosphere. One is getting wet, another one is not getting wet. That's why quicklime is used. Now, my dear friends, if this is clear, so let me tell you this thing in detail, that if you are using RCOOH, then NaOH, it will get converted into RCOONA, and then you will get what? RH. That means definitely if examiner is giving you what? If examiner is giving you NaOH X's or nothing is written or nothing is mentioned over there, then also you have to write down same product. Now, my dear friends, if tough question is going to be asked, if examiner is interested in asking tough question, then remember that what's the mechanism? What's the mechanism? So see, the mechanism, only one thing you are supposed to remember, just one thing you are supposed to remember, that RCOOH. So what you are supposed to do, give this electron to R. R will become delta negative and this H plus will go to it. So just you see R negative and H positive, they are going to form the product RH, and carbon dioxide is getting removed. That's why it is known as decarboxylation. Why have bifurcated it? Remember that carbanion is the intermediate. Who is the intermediate? If examiner is asking who is the intermediate, so carbanion is the intermediate, right? Carbanion is intermediate. So rate of reaction will be directly proportional to stability of carbanion. Remember that. Just one point you have to keep it in your brain. Rate of decarboxylation is directly proportional to stability of carbanion. Stability of carbanion. I hope this part is clear. Stability of carbanion. So how they are going to ask the questions? Good evening. Good evening. Maran, good evening. Yaslin, good evening. Rising Star, everyone, very, very good evening. Now see how they will ask questions. Question number 1. Which compound will most easily undergo decarboxylation. Which compound will most easily undergo decarboxylation? Option A, CH3, CH2, C double bond O, CH2, CH2, COOH. B, CH3, C double bond O, CH2, COOH. C, CH3, C double bond O, OH. D, CH3, CH2, C double bond O, OH. What's your answer? What's your answer, kids? Hey everyone, what's your answer? Fast, fast. I want to see the answer in the chat section. Speedily, I'm interested in seeing the answer, kids. Chaitanya, welcome. Kumudha, Tamil. Most of the people, they are thinking that Rodney chemistry padikkaradu customer. But I would like to say, it's Romba Sulubham. The things which are looking idiyappam murku, we will all together make them to be Romba Sulubham. Everyone just be very good. I can see the answer from distant rising star. B is the correct answer. Why? Now see, this is also known as beta keto acid. This is also known as beta keto acid. What's there? If you see that you are going to form carbanion, this carbanion will do resonance. It is stabilized by resonance, that this negative charge will come over here, and SBr, stabilized by resonance. So remember that beta keto acids do undergo decarboxylation even without help of NaOH and calcium oxide. Simply heating. Remember one note, everyone. Keep one note in your brain. Beta keto acid as well as one more thing is there. Beta and gamma double bond if present. Double bond if present. These two type of compounds undergoes decarboxylation simply on heating. These two type of compounds undergoes these two types of compounds undergo decarboxylation simply on heating. Just provide some heat, they will show decarboxylation. Now what's the reason? You can easily get the reason. One thing you have already seen, CH3, CH2, C double bond O, CH2, COOH, or if compound is given like CH3, CH double bond CH, CH2, C double bond OOH. Can you see any similarity in both these two type of compounds? Can you see any similarity in these two type compounds? Just see, wherever COOH is being attached, just what you are supposed to do, take this electron and give this electron to this carbon. This electron will do resonance with this, and same over here, give this electron to this carbon, it will do resonance with this. Can you see, kids? Everyone, just to let me know. Is it visible? Are you getting it? That here the resonance will take place and here also the resonance will take place. Both are being SBR. That means stabilized by resonance. So they will undergo decarboxylation simply on heating. If it is clear to each and every one of you, don't forget to show green hearts. Let me check that what's going on. People are able to understand or not. Kids, your future, your selection is not only in my hands, that is equally in your hands too. If you are responding properly, God is watching everyone. Whatever I say, whatever I teach, I want to see equal reflection from each and everyone's side. So soda lime reaction. Now another question. Next question. Once again, arrange the following. Arrange the following in decreasing order of rate of decarboxylation. Decarboxylation. Ready? I will give two questions based on this. I will give two questions based on this, and I hope that everyone is ready. A CH3 CH3 COOH. B CH3 CH3 COOH. C CH3 CH2 COOH. D CH3 COOH. Write down in the chat section in decreasing order. What's your answer? Very good, kids. That's really fantastic. Fast. Speedily, I want to see the answer. If you're not giving the correct answer, then remember that you are going to mark for negative in your examination, everyone. So if you really want to get good marks, write down and check it out. What's your answer? Kids, do let me know. If your answer is matching like this, D, maximum D, maximum by D, then C, then B, and then A, then your answer is absolutely correct. Because see, its carbonyl is 1 degree, its carbonyl is also 1 degree, but less stable because this is applying plus I, and here 3 plus I they are applying, so its carbonyl is least stable. Can you see? Its carbonyl is least stable carbonyl, least stable carbonyl. Can you get it, kids? So least stable carbonyl, and its carbonyl is 2 degree, and that was 3 degree carbonyl. Can you see, everyone? If you got it, then write down yes, you got it. Now, next one more question. A is CH3 CH2 COOH. B is CH2 double bond CH COOH. C is CH triple bond C COOH, and D is C COOH. Yes. Kids, fast, fast. Muthu, how are you, Muthu? How it's going, Muthu? Everyone. Fast. I need the answer. Why, kids? Why the answer is coming late? Quick, quick, quick. Quick response. Why quick response is not coming, kids? I'm waiting for your answer, everyone. Baba HSP is waiting for your answer. DCBA. DCBA. Fantastic. Who has given this answer speedily? Arun. Kamaleshwar. 1111. Very good. Fantastic. Now see. Correct. Absolutely correct. D, C, B, and A. Why this answer is correct? Let's see. This is carbanion stabilized by resonance. Now this carbon is sp hybridized, this is sp2 hybridized, and this is sp3 hybridized. As the percentage of s character is changing, their electronegativity also gets changed. So negative charge is more stable on more electronegative atom. Remember that. For these three, the key point is negative charge is more stable on more electronegative atom, more electronegative atom. Can you get it, kids? Everyone, for these three. And this is stabilized by resonance because just a second, kids. Wait. Let me put this light a little bit upper side. Just a second, kids. Just a second. Now Baba has to become mechanic. Baba has to play one role, that Baba has to become mechanic also. Now little bit, let me shift. Just a second, kids. Just give me a second. Now let me check it out. Now also it's there. Give me a second, kids. Just a second. Now also it is there. Just a second. Now it is also there. Just wait. Now it is also there. Now what should I do? Please don't disturb. Now it's gone. Now my face is glowing, kids. My face is glowing. Hames, hey, welcome, Hames. Now Baba's face is glowing or not? Just do let me know. I tried my level. I never give up, kids. What you got, what the message you have got from this, never give up. Okay, now after this, let's see the second preparation. I hope that everyone is ready for the second preparation. Kids. What's that? The second preparation is, you know very well, that's very, very important, the second preparation. And that is not only for alkane. That preparation holds a hell lot of weightage for alkane, for alkene, and for alkynes. Can I get the name in the slide is not clear. Which slide? Chaitanya, which slide is not clear? Which slide is not clear? That's name. Anyone? Any guess? What should be the name of that reaction which holds a hell lot of weightage for all three preparations? Its name is Kolbe. Kolbe's electrolysis. Do let me know. Kolbe's electrolysis is for what? It is equally important for preparation of alkane, alkene, alkyne. We can prepare alkane with this. We can prepare alkene from it by this method. We can prepare alkyne by this method. So I will tell you all these three preparations in one go. Just whatever I'm telling you, you have to focus on that. My dear students, first I will tell you each and everything in detail, and then I will give you the short trick. Okay. Public demand, do let me know. First, you want to know the short trick for all these three preparations, or first you want to know the in-depth way? Which way you want to know the first? Do let me know in the chat section. Baba is waiting for your answer. Baba is waiting for your answer. Do let me know in the chat section. First, you want to know the short trick, or you would like to go with the in-depth knowledge? Which one you want first? Do let me know in the chat section, everyone. I will go with that thing. Detail, then short trick. Okay, done. G-sub. First detail and then short trick. Okay, now see alkane preparation. First, let me tell you alkane. Alkane preparation by Kolbe's electrolysis. First, let's see alkane preparation by Kolbe's what? Kolbe's what? By Kolbe's electrolysis. Kolbe's electrolysis. There are two Kolbe. One you study in class 12, that is salicylic acid preparation, and this is another Kolbe's electrolysis. Kolbe's electrolysis. Kolbe's electrolysis by Kolbe's electrolysis. Let me write down it separately. Alkane, Kolbe's electrolysis. Remember that what I have written, electrolysis, so that you should not confuse with class 12th. Kolbe's electrolysis. Let's see, kids. In this, what we are supposed to take, we will take RCOO Na aqueous. Aqueous means water, and then we will supply current. Ta-da-da! Current. Hey, current. Current. Kids, we are going to supply current. Hey, current. Let's see the current. Which one is current? Which one is current sign? Current. Okay, let me see. Wow, the current sign. Zoom. Current to Rexona. We are supplying current. Show, pow, spark, shock. Where we will supply the current? In the electrolytic tank, where the electrolysis is going to happen, in the electrolytic tank. Let me draw the electrolytic tank. Let me draw the electrolytic tank. This is the tank. Tank. This is your electrolytic tank. Then I will put one anode, one cathode. How to make anode and how to make cathode, kids? If I want to make anode, I will say it is anode if it is attached with positive terminal of the battery. Remember that. Don't get confused with electrochemical cell. There at anode oxidation takes place. That's why that is negative terminal. Here, yes, we are not generating the current. We are supplying current from the outside. So the anode is positive terminal because it is attached with positive terminal. The battery, this is the anode. Hey, my anode, my dear Kuti Chetan, remember that whatever the cell is there, at anode always oxidation will take place. Oxidation means loss of electrons, always loss of electrons. Now let me draw cathode. Are you ready? Baba is going to draw cathode. Cathode means attached with negative terminal of the battery, that is being cathode. Irrespective of the cell, remember that at cathode always a reduction will take place. Reduction. Now my dear students, the salt is RCOO negative. RCOO negative, that is positive terminal. So RCOO negative will be over here and Na plus will run toward this side. Now my dear friends, RCOO negative has a negative, so it will go towards positive terminal of the battery and this will go towards negative terminal of the battery. At the same time, water is OH negative and partial H delta positive. So water will go to this side also, will go to this side also, or I can say water's H plus will go over there and OH negative will shift over here. Clear? Is this diagram clear to each and everyone? This much is clear? Hey kids, if this much is clear, then what you are supposed to do? At least show some green hearts, kids. If this much is clear, Baba would like to see green hearts, kids. Otherwise, I am not going to talk to you, kids. I will not talk. Have some water. Have some water. Always keep yourself hydrated. How's the diagram, kids? You never appreciate your Baba. How's the diagram? At least some appreciation should be done. At least some likes should be smashed. Kids, what are you? You are always living in fear. Oh, when this will get completed, when that will get completed, when I will get my selection. Always getting in fear. Don't fear when Baba is here. No fear when Baba is over here, kids. Why to fear when Baba, your Baba is over here? Very good, Dishant. The diagram is awesome. Wow, kids, that's like a good boy. Now, let's see at anode. Let's see at anode. At anode. Let me check it out. What is going to happen at anode? R, C, double bond O negative is going to release one electron. Hey, Chumu, Champas, Chumu, just go away, go away. So it will release one electron. After releasing one electron, R, C double bond O, O. Now it was having 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now one has gone. How many left? 1, 2, 3, 4. Now 1, 2, oh, 1, 2, 3, 4, 5, 6, 7, 8. Hey, no. Already 2 are over here. 1, 2, 3, 4, 5, 6, 7, 8. So 2 are over here. 1, 2, 3, 4, 5, 6, 7, and this one. 7 electrons, right, kids? Because he can ask anything. He can ask anything. The examiner can ask anything. So remember that. Examiner can ask anything. Now, my dear students, oxidation. Oxidation means loss of electron. Electron has been lost. So it is undergoing oxidation. It is acting as a reducing agent. Am I right? This is acting as a reducing agent. Are you getting my point, kids? Everyone, are you getting my point? This is acting as a reducing agent. Now, whenever you drink cold drink, who is the first one to leave it out? Who is the first one to leave that bottle? Who is the first one to leave that bottle? Carbon dioxide. Carbon dioxide says, hey, I want to go. I wanna go. I will go away from you by taking this electron. So CO2 wants to go. CO2 is going kitching. CO2 is good leaving group. Green color is my favorite. Yes, green leads photosynthesis. So CO2 is a good leaving group. CO2 is a good leaving group. Lg means leaving group. So it will go shapak. R is saying ingeva. CO2 is saying na. I want to go. I will go. So it has gone as a gas. I am going. You just waiting. I'm going. Now, my dear friends, R free radical is saying, hey, what should I do now? I am the free radical now. What should I do? I'm feeling very bad. I started crying. Now, Champa is my assistant. Champa said, okay, dear HSP, why can't you do one thing? There are a number of molecules. If we take 1 mole, that means 6.022 into 10 raised to power 23 molecules. So there are neither 1 molecule, 2 molecules. There are n molecules. Number of molecules. Now, if I take 2 molecules, if I multiply by 2, kachak, 2. So here will also be 2, kachak. So here will also be 2, kachak. So here will also be 2. Now, the major part will be these 2 R free radical will combine. These 2 R. Ingeva. Come over here. These 2 will combine to form ra. R and R. Alkane. Single bond formation has taken place. So this is happening at anode. If 1 molecule of alkane is getting formed, then 2 moles of carbon dioxide. So if this alkane is gas, my dear friends, remember that. Here the examiner will ask question. If this alkane is gas, 1 mole of alkane is getting formed. At the same time, 2 moles of carbon dioxide will get released. So total 3 moles that he can compare anode with cathode. He can compare anode with anode. At anode, what is happening? If 1 mole of alkane is getting formed, at the same time, 2 moles of carbon dioxide is getting formed. This is clear. If clear, then what you're supposed to do, kids? When 1 mole of alkane is getting formed at the same time, 2 moles, that means 1 raised to 2 alkane with respect to carbon dioxide is getting formed, kids. Am I right? Am I right? Now, what will happen to these electrons? It has lost electrons, so these 2 electrons will go. Hey, I'm coming. Where these 2 electrons are going, let's see. Let's see where these 2 electrons, this is the story of all about electrons. Your HSP Baba treats elements like human beings and electrons like money. Money is flowing. I'm going. So let's see where it is going. So let's see the story at cathode. I hope that everyone is enjoying. Let's see at cathode. What is happening at cathode? At cathode, always reduction takes place. Always reduction takes place. That is gain of electrons. That is gain of electrons. Gain of electrons. Or electron or electrons, right? Now see, out of sodium, there is H plus from water, who is having more tendency to gain electron. Definitely sodium will not gain electron, can't gain, because its SRP is negative. Hydrogen's SRP is 0, but hydrogen is in the form of water, so it will gain electron, more SRP. Its SRP is more SRP, standard reduction potential. So 2 hydrogens will gain 2 electrons, and it will convert into twice of hydrogen, and 2 hydrogen atoms will further convert into H2 gas. So which gas is getting evolved at anode? Carbon dioxide as well as alkane. Which gas is getting evolved at cathode? Hydrogen gas. So if examiner is asking what is the ratio of the gases which are getting evolved, so kids, what you're supposed to say? Gases ratio evolved at anode and cathode. So we have seen, till now we have seen at anode, what has happened, kids? 1 mole of alkane 1, then 2 moles of carbon dioxide, this, so total moles 3 moles. And if they are asking at cathode, anode versus cathode, so at the same time 1 mole of hydrogen gas. I hope this point is very much clear to all of you. If yes, don't forget to show green hearts, anode versus cathode. Once I look in the chat section should be full of green hearts. That's my demand. So now this is detail. Now it took too much time, but in the examination we will not be having this much of time. So what we are supposed to do? We should know the trick also. How many of you want to know the trick? I want to see fire in the chat section. Everyone, show me some fire in the chat section if you want to know the short trick. Da-da-da, Baba HSP. Baba HSP's short trick. It's a time to get short trick by Baba HSP. Baba HSP. Baba HSP's short tricks. Now see kids, what are you supposed to do? For example, you are writing this CH3 C double bond O Na. In place of Na they can give you potassium also. Now write down water, water HOH, one more mole, repeat it, CH3 C double bond ONA HOH. Now supply current. Current. Now kids see. It will form the free radical. Free radical. Break the bond from here. Break and make it over here. Break it from there and make it over here. Breaking and making. What will you get? Just to let me know. CH3. CH3 is being ethane gas. Am I right? Ethane gas. Now where you will get ABC. It's not KBC. It's ABC. Accelerator, brake and clutch. You know ABC. But what is the meaning of ABC over here? A means anode. B means bridge. And C means cathode. C for cathode. Remember that. What you are getting at anode. What you are getting at cathode. La la la. La la. Now what is left? What is left over here? Just see, just focus over here. Everyone. CO2. Oh my. CO2. CO2. Oh my. CO2. 2 moles of CO2. 2 moles of CO2. All this I will get at anode. These two things I have got at anode. These two things I have got at anode. This is the story of anode. Now what is the story of cathode? Let's see. Hey cathode, what's your story? Just see, this is the story of cathode. What I will get at cathode? I will get hydrogen gas. Hydrogen gas. Now what is the solution? That is the bridge. What I will get? What I will get, kids? NaOH. NaOH. I will get NaOH. And this NaOH will make solution to be more basic. So pH of solution will continuously keep on increasing. During the reaction, pH will keep on increasing. That was anode. This is at cathode. This is a short trick. Once if you have known, then we can easily prepare anything. Now apply short trick and tell me the answer of this question, right? Just apply this trick and I'm going to give you the question and you have to answer that question. Are you ready? The short trick is good. Hey kids, if you got it, once if you understand, did you really understand? Have you understood? If yes, what are you supposed to do? What are you supposed to do? Tell me. Show me some green hearts. Show me some green hearts. La la la. Now examiner will give you this question. Just see whether you are able to give the answer or not. CH3 CH3 COOK aqueous current. Do let me know what should be your answer. I'm waiting in the chat. What should be your answer? Do let me know. Before I write down the answer, I want to know from your side. What I will do, kids, in the examination, if I don't know anything, but I know Baba HSP short trick. Hey Baba HSP, you are really good. You have told me something that I can never forget. Never ever forget. You are really awesome, my Baba HSP. My Baba HSP. My Baba HSP. Break the bond and make over here. Break the bond from there and make over here. What you will get? Which alkane you will get? You will get CH3, CH, CH3, CH, CH3, CH3. IUPAC name 1, 2, 3, 4, 2,3-dimethyl butane. Everyone, let's see. Oh my God, everyone has written before me. When I'm going to write, oh my God, just immediately you people have given the answer. Ha, G-sub, G-sub, very good, very good. Telegram, okay. So, what's that? T.me slash HSPN. This one, right? T.me slash HSPN, right? This much is clear to all of you. Are you ready to prepare alkene kits? Is everyone ready to prepare alkene? Kids, are you sleeping or you are getting S. Kumida? Thank you. Thank you, S. Kumida. I will ask the team to share all the 3 PDFs. The lecture I took for GOC and then Isomers, and today's lecture that is of hydrocarbons. All the 3 PDF definitely you will get for sure, kids, right? Now, alkene preparation. Alkene by Kolbe's electrolysis. Everyone ready for this? Alkene by Kolbe's electrolysis. Let's see whether it is going to write correctly. Yeah, you are my boss. Champa, you hired. Thank you. Champa has helped me a lot. Champa always helping me, kids. This is done by Champa. See the font. Very good. Thank you, Champa, for helping me. Now see, kids. Just apply that trick. You will get the answer. CH2 COOK CH2 COOK water HOH HOH and then the current. Now see, kids. Now see. Don't forget the name of these compounds. They always holds a hell lot of weightage. You know each and everything, but if you don't know the name, then what you will do? Ring rising, very good. Okay, rising star. Now see, kids. Its name is so potassium succinate. What is the name of this compound, kids? Potassium succinate. Now just apply that trick. Break the bond from here. Just start forming bond over here. Break the bond from over there. Just start making bond over here. So they will combine. Which gas you will get, kids? Ethene plus 2 moles of carbon dioxide. Shapak. Twice of CO2. Am I right, kids? It's easy now. All these things I have got at anode. At cathode, I will get hydrogen gas. And in the solution, what I will get? I will get twice of KOH, and pH will keep on increasing, and that is at cathode. That is at cathode, and this is in the solution. Is it clear to all of you kids? If by chance examiner has given question, let's see what's the question. Question is, examiner is interested in giving question. Write down answer the chat. Which alkene you will get? Which alkene will you get? I want to see the answer in the chat section, kids. Which alkene you are going to get? Fast, kids, fast. Wow, rising star. Awesome. All the best. Butane, perfecto. Dishant, perfect. Now break the bond from here. Just break the bond from here. Ding, ding. And make in between these two. Start making in between these two. Your answer is CH3. CH, double bond, CH, CH3. Butane. Rest of the things you know very well. Got it? Now one question. Not the question. First, let me tell you about alkyne preparation. Let's see alkyne preparation. Everyone ready for alkyne preparation? Alkyne by Kolbe's electrolysis. In place of alkene, let me write down alkyne. What's happening, kids? Ting, 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 ting. Yeah. Alkyne. Alkyne by Kolbe's electrolysis. Now see what you're supposed to take. CH, double bond, CH, C double bond O, Na, C double bond O, Na, aqueous, and then current. Now you can see. Now each and everything you know very well. Only the thing which you are supposed to know, that is the name of this compound. This is known as sodium malate. Everyone say sodium malate, from malic acid. Sodium malate. What are you supposed to do? Just break the bond from here and make it over here. What's your answer? What's the answer? Ethyne is the answer. I hope that all three compounds, alkane and alkene and alkyne, you got prepared by this method. Nalla iriku. Wow, that's really awesome. But why? Where are the green hearts? Where's the fire? That is missing, kids. And what are the likes? Let me see the score of likes. 108. Kids, make it 120. Can you do that? Is it possible to make it 120? Kids? Now, one reaction is there which is from class 10th standard. I would like to say it is from class 10th standard, and generally it happens that we forget this reaction. This is of class 10, but equally important for your NEET and IIT. Aluminium carbide. How will you write aluminium carbide? Al4C3 plus water. will get what? Methane gas, CH4. Remember that. Cram it. Its name is aluminium carbide. What is the name of this compound? Aluminium carbide. Just remember it. Just remember it. Just like calcium carbide, you must have studied, that is given in NCERT, class NCERT. Now this is given in class NCERT, class 11th, NCERT. Class 11th, this reaction, you know, calcium carbide, CaC2 plus water. Then what will you get? You will get acetylene gas. This to everyone knows. This to everyone knows, but you don't know about methane. So this is calcium carbide. Am I right, kids? This is ICC, class 10, ICSC board. Am I right, kids? Whatever I'm telling you, it's like same thing, correct thing, giving you the correct information or not. Thank you, Dishant. Thank you, Dishant. Very, very thank you. Now, see, kids. Next preparation is whenever you take Ri plus nascent hydrogen. So one hydrogen R will take, another hydrogen I will take Hi. It's simply reduction. It's simply reduction. Alkyl iodide is getting changed to hydrocarbon. Simple reaction. Very, very simple, I would like to say. It's simple reaction. Everyone got it? Nothing is there. Now what I am going to tell you, kids. One more thing I would like to say, it is given even in class 10th. So equally important for NEET, JEE, class 10th standard people also. Oh, Dishant, yes. Very, very good chemistry is given in class 10th ICC board. Now see, kids, if I say any aldehyde or ketone, any aldehyde or ketone is given over there. This is either aldehyde or it is ketone, doesn't matter, irrespective of aldehyde, ketone or its reactivity. What you will get R. If you notice, then in place of oxygen we will get two hydrogens. Now how these two hydrogens will come? There are three ways. One and a mono. Ek, do, teen. Three ways we can do this conversion. First is Shapak. What's that? Anyone? Any idea? Wolff-Kishner reduction. Wolff-Kishner reduction. What we are supposed to take? Hydrogen. KOH, ethylene glycol. Remember that the medium is being basic. Or we can achieve this target by Clemenson's reduction. Which reduction? Clemenson's reduction. What is that? Zinc amalgam. That is zinc HgHCl. Now remember that in that nitrogen is the side product. Once in AIMS they have asked this question. Nitrogen gas is the side product that is eliminated. Either this or this. There is one more way by which you can achieve this. That is your Hi red phosphorus or by Hi red phosphorus. Now these two are in acidic medium. Remember that HCl is acid, Hi is acid, that is basic. Why I'm telling you, why I'm focusing over here? See the question. Once they have asked this question in AIMS, see, the question was, Sometimes it's missing. Question was best reagent for following conversion. For following conversion. See what is being affected and what is being remaining unaffected. So reagent you are supposed to use A, hydrogen KOH, ethylene glycol, B, zinc amalgam, HCl, C, HI red phosphorus, D, methyl magnesium bromide, zinc and water. Yes. Let me see who is going to get the correct answer. Fast. Yo. Kumedah A. So Kumedah, everyone, Dishant, why you are going with B? B is wrong answer. Even C is wrong answer, kids. Only A is the correct answer. Now ask me why. Pucho kyun? Ask me why. Pucho kyun? Just ask me why. I will tell you. After 3 more lectures, I will teach types of reactions. Suppose if this is goat, if I say this is goat and this is what to say? This is goat and this is grass. This is grass. Okay. Now, which thing should I take? Which thing should I use? And what I am supposed to have for protection of this goat? If I say this is elephant, this is lion, this is tiger, and this is rat. Now, whom out of these 4 options, which one should I use so that that animal should eat grass? Grass should not be left, but that animal should not attack on goat. Tell me, this story I made it right now. I made it right now. Now, this is a base. See why I made a story and how I made a story. Base will not attack, and this is also base. Base will not attack base, so it will remain protected and it will attack over here only. This is the acid. This acid will attack on base also. If I am going to use this, if this would have been used, this will attack on OH also. If this would have been used, this will attack on this base also. How is the story? I need 1,000,000 stars for this story. The story, how is the story, kids? Do let me know. I want to see from each and every one side if the story is really awesome. If the story is really awesome, then do let me know, kids. How was this story? Kids, do let me know how was this story. What story I framed out is a really $1,000,000 story or not, kids? Do let me know. This is brain. This I made, this is brain. Story has gone to your brain or not? This was a really awesome story or not, kids? Do let me know in the chat section. Now, next one, next preparation I would like to say, that is Wurtz reaction. Wurtz Khalifa, you know. But right now we are going to deal with Wurtz reaction. Which reaction? Wurtz. Wurtz, not the Khalifa. It's Wurtz reaction only. Wurtz reaction only, right, kids? Now, everyone must have studied about Wurtz reaction, that simply we will say, and during Wurtz reaction, Rx twice of Na Rx, then NaX will eliminate out, and RR we will get Rara, R with R twice of NaX. So we have got symmetrical alkane. What do we have got? We got symmetry is there. So symmetrical alkane we have got. Now what can be prepared, what cannot be prepared? Before I move ahead, let me see that am I having number of questions on Wurtz reaction or not? Let me see, kids, because I have done a lot of homework for you kids. So let me use that how much I am having on Wurtz reaction. Let me check it out, kids. So see, kids. See, this is for you, kids. This is for you. This is for you. The questions you will get, see explanation, questions, everything you will get, see. Are you getting my point? These notes you will get, kids. How much hard work I have done for you. See, beta keto acids. Can you see? These notes I made for you. Can you see, kids? The whole 3 to 4 days I have spent on making notes for you. Kids, you're liking or not? I will come to that. I will come to that. I will come to each and everything. I will come to each and everything. How many days? See, Wurtz reaction. Now see. I told you I made notes for you, kids. What's your doubt? Nikunj, I will take your doubt. Now see, it's really awesome or not? Now see. An alkane with even number of carbon atoms we can prepare. Now see. Isopropyl chloride Na dry ether. What will you get? Just check it out. Will you get this answer, whatever is written on the board or not? Will you get this answer or not? Now, next one. If you take this one, only one equivalent. If this is given one equivalent, see, I promised you that I will take least time, but I will teach each and everything. Just to manage the time, how much hard work I have done, kids. Nikunj, I will take your doubt. I will take your doubt at the last. Okay, Nikunj, I will take. Now see, kids, just to save time, this chlorine will go, one equivalent is given, so bicyclo, highly unstable. But if one equivalent is not given, then what it would like to do? It will do that intramolecular one, or it will do intermolecular one. Two molecules are combining. This is stable compound. This is stable. and that was unstable. If nothing is given, then also go with this one. If axis is given, then also you are supposed to go with this one, but only if they have marked one equivalent. If they have marked just one equivalent, then you are not having any choice. Then definitely if this one equivalent is marked, then you are supposed to do good with highly unstable one, because intramolecular Wurtz reaction will take place. Are you getting my point, kids? Then there are no choice. You have to go with intramolecular one only. Right? I hope it's clear to all of you. Now see, this one you are able to understand. The smallest hydrocarbon which contains secondary carbon. Okay, let me give the answer of Nikunj's question. The smallest hydrocarbon which contain secondary carbon. Now see, as Nikunj has asked one question, let me explain Nikunj's. Let me give answer to Nikunj's question. What is the question? You are free to ask your question. Smallest, this is the question asked by one student from the chat section. Smallest hydrocarbon containing secondary hydrogen, secondary carbon, containing secondary carbon. Now see, make secondary carbon CH3. Now CH3. Now CH3. Now nothing can be smallest than this, isobutane. So see, rest are primary, but this is being secondary. I hope Nikunj you got your answer. Is it clear, Nikunj? 2-methyl propane. Rising star even has given the answer. Okay, now kids, just see, it is having two types of mechanism. The ionic mechanism, but you won't be able to understand. So let me tell you from my side. I don't think you will be able to understand. Okay, so let me tell you from my side. Right, kids? Wurtz reaction follows two types of mechanism, ionic mechanism and free radical mechanism. As is everyone ready to understand these two mechanisms? Just see why I am saying two types are possible. Why two type of things are possible. Now see, kids. Let me tell you. If I say that I am provided with methyl or ethyl chloride, say if I say I am provided with ethyl chloride and I am provided with sodium and dry ether. Why dry ether? If moisture is there, that will react with ether. Now what main product I will get? What other products I am supposed to get? Each and everything the examiner will ask. What I am saying? What is the main product and what are the other side products? Are you ready? To understand this, my dear friends, to understand it completely, let me go back to that original one where I was teaching you, because I'm writing here and I'm supposed to give you each and everything that is for the first time, so that your notes should also be proper. Each and everything you can understand. Now see, the question was that ethyl chloride is reacting with sodium and dry ether. Everyone will write down the answer as butane. Everyone can write down this answer, kids. Am I right? But If examiner is asking about other products, then only few students will be able to write down these other products. Majority of the people will get failed over here. So this is a killing thing. This is not easy job. And here we have to focus. Is everyone ready, kids? Is everyone ready? Now, remember that where you have to focus, see kids, ethyl chloride is there. Once the ethyl chloride is releasing or going away from it, what it will produce? It will produce CH3, CH2 plus, right? Am I right, kids? Am I right? Exactly. Yes. Now, if I say there are number of molecules, if I take 2 molecules of it, CH3, CH2, Cl, then I will get 2 molecules of it, CH3, CH2 plus. Now, if sodium, number of sodiums are there, suppose if I take 2 sodium metals and they have become twice of Na plus and it has given 2 electrons, what do you think? These 2 electrons will be taken by one molecule. Suppose if I say this is A molecule, this is B molecule, what do you think? These 2 will take one electron, or both the 2 electrons will be taken by one, because it is having 6 electrons. It is having 6 electrons. Never try to cram out the mechanism. Just go with the flow, what your brain speaks. What your brain speak, what your brain say, just go with that flow. Just do let me know. Tell me, kids. One molecule will accept 2 electrons, or one electron will be taken by 2. Now remember that 2 possibilities are there. How many possibilities are there? 2 possibilities are there. Am I right? Two possibilities. If you explore these 2 possibilities, the answer is just in front of your eyes. Now see the 2 possibilities. Let me divide the board. The first possibility is that this has gained both the 2 electrons, then this will become what? Negatively charged. Earlier also it was unhappy, right now it's also unhappy. Earlier it was unhappy because of only 6 electrons and plus charge. Now it is unhappy because of the charge. Electrons are okay, but charge is there. Charge is like a disease. Charge is like disease. Charge should not be there on the compound. In both the 2 conditions, it has found itself to be unstable. In both the 2 conditions, it is unstable. Earlier also it was unstable. Right now also it is unstable. Now what it will do? It will go with this compound, the another one. Hey bro, you are having just 6 electrons and I am having 8 electrons. Why we should not do one thing? Let's shake hands. I'm yours, you are mine. Let's form a bond. We will live together. Oh my dear. Yes, whatever you are saying is correct. Absolutely correct. They have formed CH3, CH2, CH2, CH3, butane. But, my dear student, the first approach was not able to explain number of other things. To understand number of other things, they have gone by like this. Just apply your brain, you will get the answer. That one molecule is taking one electron, another molecule is taking another electron. Am I right? This is also the possibility now. Second approach. So they will be like this. The free radical mechanism. Now, in this free radical mechanism, two possibilities are there. Either they can combine together to form butane, another thing which is possible, that they can undergo disproportionation reaction. Have you heard this name? Disproportionation. Have you ever heard this name, disproportionation, kids? Same atom is losing electron as well as same atom is gaining electron. This is done by the same atom. Oxidation as well as reduction. It is redox. All disproportionation are example of redox, but all redox are not disproportionation. Right, kids? So what is going to happen? See, my dear students, if I say this carbon is losing hydrogen, this carbon is losing hydrogen, so loss of hydrogen is oxidation, loss of electron is also oxidation. In both the two cases, this carbon is undergoing, say this carbon is undergoing, say kids, do let me know in the chat, oxidation. And this is going to this carbon. This carbon is accepting this hydrogen. This hydrogen is moving with electron to that carbon. So it is undergoing kids, reduction. Just see to it. One carbon is undergoing oxidation, another one is undergoing reduction at the same time. Deshant, very good. Deshant is giving correct answers, and Deshant is saying, I will remain till the end. Wow, Deshant, salute. And I will try to complete this class as early as possible with each and everything, telling you, giving you, making you understand each and every concept. I'm not going to leave even a single concept, kids, even a single concept, right? So now it will convert into ethene. It will convert into ethene. Should I write down over here only, if you are able to understand? And that will convert into ethane. Do let me know in the chat section if you got it. Ethene and ethane, these are the side products. If examiner is asking in detail, definitely he will ask, and you have to answer for it that yes, these will be the answers. And in minute amount also, whatever I'm going to get, I should know. Now, kids, if you are able to understand, do let me know, kids. Now, one thing you know very well, why Wurtz reaction is suitable for preparation of symmetrical alkane. Alkane with odd number of carbon is not prepared by this method. That means Wurtz reaction is not suitable for preparation of alkane with odd number of carbons. Now, kids, when I was in my school time, I was thinking that we can prepare. Why people are saying we cannot prepare? Odd number alkane can be prepared, but that's not economical. It's not economical. Now see kids, why it's not economical? If we want to prepare propane, just see, we have to take methyl chloride, we have to take ethyl chloride, sodium diether, right kids? Now, my dear students, whenever you are going to take chemicals, suppose I'm having tea, do you think there will be one molecule, two molecules, three molecules? If you take 1 liter of water, its molarity is 55.55. That means 55.55 moles of water is there in 1 liter. 55.55 moles means 55.55 into 6.022 into 10 raised to 23 molecules of water are there. That means number of molecules of this chemical must be there. Now see, this will do self-Wurtz reaction. Its self-Wurtz will produce ethane. Itself will produce butane gas, ethane gas, butane gas, and their cross will produce what? Their cross will produce propane. All of them are being gas, and it's very tough to separate gaseous mixture. During COVID pandemic, there was scarcity of oxygen cylinder. We know that in the air, O2 is there, N2 is there. Then why the scarcity was there? Because to separate gaseous mixture, to get pure oxygen from that air is not that easy. Once you can prepare, but you can't separate it easily, that will require too much labor charge. That is not economical. Somebody is going to put industry, and if he is not able to get money from that, then why he will do that? So remember that it's very tough to separate gaseous mixture. It's very tough to separate gaseous mixture. And my dear students, that's why it is not economical, and that's why people are not using this Wurtz reaction for this preparation. Odd number alkane. I hope this is clear. If it is clear, I want to see green hearts in the chat section. Everyone, just do let me know if it is clear. Show me green hearts in the chat section so that I can proceed further. Now, friend of Wurtz, one of his classmates was Fittig. Fittig said, hey, thank you everyone for telling this much about your Baba HSP. Really, you kids are so awesome. I'm so happy to see you kids. I'm dying to teach you kids. You are my dream. Your selection will be the best dream. And selection doesn't mean everything. Once you are studying, then definitely one day God, Almighty God, will give you some seats, some successful goal you are going to achieve. You are really so awesome, kids. Now, see, kids. One of his classmates was Fittig. Who was his classmate? Fittig. What Fittig said? Just listen. Fittig, not Bittig. Remember that what I'm saying. Fittig. Fittig. Tick, tick, tick. Fittig. Now Fittig said, whatever Wurtz has prepared for alkyl, I will prepare for aryl. He prepared for aryl. So to get into limelight, he has used aryl halide. Remember that. What is being used by him? Aryl halide. Mainly, he has used allyl iodide. because iodine is a good leaving group. I is good leaving group. So 2 moles of this, twice of sodium and dry ether is polar aprotic solvent. So diphenyl is the answer. Diphenyl is the answer. Now both has become star. Both has become star. Now one day media said, oh, you are a great star, but we have heard that you are using sodium. So some laborers, some daily workers of your industry, they got dead because of explosion. They said, oh my God, oh my God. It's not fitting, okay? So they said, oh my God. So one of his classmates, he was Frankland. He said, oh, I'm coming. So next reaction's name is Frankland. Everyone say kids, Frankland. Just say everyone. Frankland reaction. Frankland reaction. Now, what Frankland did, kids, he has not used sodium. In place of sodium, kids, do let me know what he has used. Twice of Rx. So how he has used Rx? The rocks. Hey rocks. Hey rocks. What are you doing over here? Just listen, rocks. Zinc. One zinc said, I will take away these two X. X is mine, not your. Oh, X, where are you going? No more, I want to live with you. So, Rara, symmetrical alkane. And ZNX2 has gone. Now media said, hey Frankland bro, your bros bro, that you're not using sodium, your workers are safe. So he has become public figure. He has become public figure. Now, one says zinc was coming, and there was rain. So zinc got wet during that rain. So media person said, oh, Franklin, what happened? Where your zinc has gone? Now, each and everything, one owl was listening. Owl was sitting on the tree and he heard all these things. Now, media person was waiting for somebody else. Now, owl has become man. Owl has become man. Man. Kids, what's the name of reaction? Man. Owl has become man. Reaction's name is man reaction. Man reaction. Everyone say kids, man reaction. Now, what magical thing is done by Ullman? What magical thing is done by Ullman? He has neither used sodium nor he has used zinc. He has used copper. He has used copper. What is used by him? Copper. Now workers were remaining safe and copper was not getting affected by water also. So he has provided some heat and yay, now media said you are really rock star. Who is the rock star now? Ullman has become rock star. Everyone started appreciating Ullman. Hey Ullman, how you're feeling? In our country there is He-Man, Spider-Man, Hanuman, Gurdas Man. You are Ullman. How you're feeling now? Thank you, Neeraja, thank you. Kids, you are really liking? Now see, kids. Now, one media person said, all of you are preparing symmetrical alkanes. Nobody is able to prepare what? No one is able to prepare unsymmetrical alkane, asymmetrical alkane, alkane with odd number of carbon. Now, he said, oh my God, so there was one. Just think what? You know, fishes, they are having gills. This was man, owl has become man. Now there is Gilman's reagent, just see. And the reaction is one house. The reaction is one house. What is the name of that house? Let me tell you. Corey-House. Kids, which reaction I am going to deal with? Corey-House reaction. Which reaction? Corey-House. And in this house, there is man, Gilman. See, funny names. These are funny names, kids. Corey-House. Everyone say Corey-House reaction. Now, why this Corey-House reaction is famous? This reaction is famous for what? Corey-House reaction. And why this reaction is famous? This reaction is famous for what, kids? This reaction is famous for preparation of both symmetrical as well as asymmetrical alkane. Both type of alkanes can be prepared by this reaction. Symmetrical as well as asymmetrical alkanes can be prepared. Symmetrical as well as asymmetrical alkanes can be prepared by this reaction. Now let's see how to move on. Twice of Rx lithium iodide CuI2 R2 CuLi. This is known as what? Remember that this is known as what? This is known as Gilman's reagent. Kids, do remember what it is known as? Gilman. That was Owlman. This is Gilman's reagent. Will you remember this, kids? Gilman's reagent. Gilman's R2CuLi, dialkyl copper lithium. Dialkyl copper lithium. Kids, now see, kids, if you want to prepare symmetrical alkane, you take Rx, you will get R. If you want to prepare asymmetrical alkane, you can take R-X, you will get R. That R and this R were same, this R and that R is different. Asymmetrical alkane. Asymmetric, this is symmetric. I hope everyone got it. I hope that everyone got it. Now let me give you one example of it. If it's clear, I want to see green hearts in the chat section. Everyone, let me give you one example of it. For example, if you have taken CH3, CH2, Cl, Li, CuI2, you will get C2H5 whole twice CuLi. Now, if you go with this path C2H5 Cl, then you will get CH3 CH2 CH2 CH3, symmetrical alkane. Now, if you want to go through this path, isopropyl halide, remember that this should not be this can't be 3 degree. This can't be 3 degree, otherwise the elimination will take place. So your product will be CH3, CH2, CH, CH3, CH3. This is symmetrical, that is asymmetric, and I hope that everyone, I made myself clear, everyone got it. Do let me know, kids. Everyone, is it clear? Is it clear to each and every one of you kids? Now, these are the preparations we have gone through. Now, let's start with the chemical properties of alkanes. I hope that everyone is ready for the chemical properties of alkane. Are you ready, kids, for the chemical properties of alkane? Now, everyone ready, kids? Now, before I start chemical properties of alkane, let me give you one mind map. This mind map must be containing alkane, alkene, alkyne, all three together. You can take it as a Kit Kat break, but I'm not going to give any break right now. Right now, I will not give break. I'm going to give you one mind map, $1 million mind map, which holds a hell lot of weightage. Ready? Ready for the mind map? The smallest alkane is methane. Let me move with methane. This will change your life, kids. Now, methane is allowed to react with Cl2H nu. The name of this reaction is free radical substitution reaction, FRSR. I am going to teach you. So what we will get, kids? Definitely we will get methyl chloride. Everyone say methyl chloride. Am I right or wrong? Methyl chloride is allowed to react with, kids. Methyl chloride is allowed to react with Na dry ether. Do let me know what I will get with Na dry ether in the chat section. Na dry ether, what I will get, kids? This is the Wurtz reaction. Its name is being Wurtz reaction. What I will get? If you really want to get success, write down what I will get, what you will get. We will get ethane. Now, once again, if we do free radical substitution reaction, reacting with Cl2H nu, do let me know, kids, what you will get. Cl2H nu. Photochemically, we are carrying out this reaction FRSR, free radical substitution. What you will get, kids? Definitely you will get CH3, CH2, Cl, ethyl chloride. Now, if I do the reaction with KOH alcoholic, do remember what I'm saying? KOH alcoholic, and if I heat it, what I will get? Definitely elimination will take place. E2 reaction will take place, E2 elimination, and I will get ethene, dehydrohalogenation. This is known as dehydrohalogenation. Earlier we were charging 8 to 20,000 rupees for these mind maps, but right now I'm giving you these mind maps for free of cost, kids, free of cost. Now see, one more way is there. If this would have been reacted with KOH alcoholic, remember that KOH aqueous, if we are going to react it with KOH aqueous, then nucleophilic substitution reaction will take place, NSR will take place, and we will get ethyl alcohol. We will get ethyl alcohol. This is nucleophilic substitution. And if we are reacting it with concentrated H2SO4 and heat, concentrated H2SO4 and heat at 443 Kelvin temperature, we will get ethene. This is taking by elimination reaction. And if we are treating this with water at a low temperature, this is hydration. Dilute H2SO4, leach at layer principle is applicable. We'll get once again this back. Now, if this ethene was reacted with, if this ethene, if we are going to react it with, if we are going to react this ethene with gets bromine water, you know the color of bromine water is reddish brown. Br2 water will dechlorize and we will get ethylene bromide. Remember that in ethylene bromide there is no double bond. Ethylene bromide, it's a name, journal name. It is vicinal halide, vicinal halide. Now, if this vicinal halide is treated with KOH alcoholic, KOH alcoholic, now see K plus will react with this and OH negative will take away proton. What I am saying, K plus will take away bromide. So here you will get partial positive and OH negative will take away this proton. So here you will get negative, negative, positive will form a bond. Now see kids, this is vinyl bromide. If you have studied GOC, then you do remember that this halogen is attached with sp2 hybridized carbon. This is known as vinyl halide, and vinyl halide means the halogen is forming a double bond character with this carbon, partial double bond character. So it's not a good leaving group. So you need even a stronger base, and the stronger base is NaNH2. Remember that. Sodiamide. What I'm saying, sodiamide is a stronger base given an NCRT and heat. Now you will get acetylene gas. What will you get, kids? Acetylene gas. Now acetylene is least reactive, or you can say less reactive than alkene. I will compare why it is less reactive and I am going to tell you in detail. So it will not easily react with water. So what we are supposed to do, in water we have to add 1% HgSO4 and 40% H2SO4 solution to this. Then we will get acetaldehyde. Then we will get acetaldehyde, CH3, CH double bond O. Now if you do the oxidation of acetaldehyde, you will get oxidation. Acetaldehyde's oxidation, you are supposed to use strong oxidizing agent like KMnO4, acidic medium. Then you will get CH3, COOH. Now you know very well with CH3, COOH how to prepare back methane. That we can do by soda lime reaction, NaOH, quick lime, CaO. Now my dear students, I hope this mind map is giving you lot of knowledge. It will be helpful for conversion. Let me see how many likes you have given. Let me see the chat that it is clearly visible or not. Kids, really it is going to help you a lot or not? I can see on my screen that visibility is Romba, Sulbham, Nalla Iruku. It's really awesome. I too can see it clearly, kids. Neeraj, Neeraj Sai, I will definitely teach you IUPAC whenever I am getting time. Definitely, nothing will be left. Will not leave even a single strand. Oh, Nandini, that's really awesome. That's really awesome. Kids, everyone, excellent mind map. Thank you, kids. Now, one more mind map I will give to complete each and every alkyne, everything. Should I give you right now or should I give you later on? One more mind map that is having alkynes mainly based on alkynes. Kids, do let me know in the chat section. I am seeing your um, the comments. Baba is always Baba. 1111. Thank you. Nandre, thank you. Evergreen, Kirtisimi. Later on. Okay, let me tell you the chemical properties of alkane. Okay, so let's go with chemical properties of alkane. Chemical properties of alkane. Ready, kids? Everyone ready? Kids, as I have told you in the starting, that alkanes are least reactive, so they have only few chemical properties. There are only few chemical properties. So, which chemical property is main, kids? Which chemical property do you think is main? So, halogenation is main. Halogenation is main. Remember that. Halogenation. The majority of the reactions will come under this halogenation, and this fluorine is highly reactive, so generally fluorine is not carried out. Chlorination we will do, bromination we will do, and iodine is too less reactive, so we will generally will not deal with iodination also. So main properties with which we are going to deal with are chlorination and bromination. So this is too fast, sometimes explosive also. So we will not prepare fluoroalkanes by this method. Fluoroalkanes will be prepared by which reaction? Schwarz reaction. Remember that. Kids, fluoroalkane will be prepared by kids, tell me. Fluoroalkane will be prepared by Schwarz reaction. Which reaction, kids? Schwarz reaction. Remember that. Schwarz reaction. Which reaction, kids? Schwarz reaction. So too fast, too fast, too fast, and iodination is too slow, too slow. So mainly we will deal with chlorination and bromination in this. And about chlorination and bromination, I will tell you later on one point, that it is highly reactive, so less selective. You will understand the meaning of this later on. Highly reactive, So less selective. Chlorine is less selective. What is the meaning of this? You will come to know. This is less reactive, so more selective. So definitely the chemistry we will deal with chlorination and bromination, right? Mainly we are going to deal with chlorination and bromination. Now kids, before I start chlorination and bromination, what is the meaning of highly reactive, less selective, more reactive, how to do each and everything, right? Let's move on kids, right? Let's move on. Let's see what's the mechanism. Suppose if somebody by chance is giving you such type of questions, just see CH4 and they are doing reaction with fluorine F2 in dark, F2 fluorination in dark. Can you tell me what will you get? So kids, fluorine is that reactive whether you carry out this reaction in sunlight or in dark, everything will be dark black, that is known as carbon black. Nothing will left behind. You will get carbon black. Now, if chlorination you are going to carry out kids, now if you react with Cl2 in dark, nothing will happen, no reaction. Chlorine will say, I will not react in dark. So, now methane, if you react in presence of sunlight, then definitely methane will react and it can give you how many types of product, just see. It can give you methyl chloride, it can give you methylene chloride, it can give you chloroform, it can give you carbon tetrachloride. 4 types of chlorinated products. How many types of? 4 types of chlorinated product you will get. Right kids? Now if you do this reaction in sunlight at 12 noon, 12 noon means the intensity of sun rays is too much, remember that. So once again you will get carbon black. What will you get? Carbon black. Remember that you will get carbon black. So such type of questions they can ask in the examination. One more question they can ask in the examination. Just see what is that question. The question is, brilliant question they can ask, that they have reacted ethane with chlorine Cl2 and in sunlight. This is in excess and they have provided sunlight, my dear students. Now they are asking how many types of chlorinated products. Question is, how many types of chlorinated products? Now kids, do let me know in the chat section how many types of chlorinated products you will get. That's the question. Kids, yes, Champa's promise. I want answer from each and every side. Everyone just to let me know. 9. Very good, rising star. That's the absolutely correct answer. That's awesome answer. Now see, answer is 9 kids. Everyone just see, answer is 9. Let's see why and how. CH3, CH2, you can place one chlorine over here. CH3, CH, you can place 2 chlorines over here. CH3, C, one chlorine, one more chlorine, one more chlorine over here. 3 we have got, 3. Now see, CH2Cl, CH2Cl, vicinal halide. Now CH2Cl, CH, one Cl over here, one Cl over here, CH2Cl, C, Cl, Cl and Cl. Now 6 we have got. Now see to it. CH, one Cl, one more Cl, CH, Cl, Cl, CH, Cl, Cl, C, Cl, 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 C, Cl, 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 C, Cl, Cl, Cl. So total 9. Now, once we deal with such type of questions, people start asking with themselves that what will happen if they have given question that how many all type of products with propane. My dear student, you have seen right now with ethane we have given this much of time, then only we have written the answer. If they are asking for propane, then how much time will be required? So they will never ask for propane. If they are asking question, they will ask for methane and ethane. If they are asking for propane, then see what type of question they will ask. They will not ask this type of question. What type of other question they will ask? Just see. Everyone ready? Are you getting what I am saying, kids? Everyone, are you getting what I am saying? Everyone, are you getting what I am talking to you? What other type of question they will give? Say, kids, at least try to respond in the chat where you people are getting indulged. I can't understand. Kids, whatever your teacher is asking. Nandini, what's your message? Do let me know. Let me read first. Let me read out the messages. Until that time, you smash the like button, kids. Let me read everyone's message. Once let me read everyone's message. Write down. Tell me what do you want to say, kids. I'm reading everyone's chat. Do let me know. 150 likes are there. Now do let me know, kids. Nandini, let me see what you are writing. Write down, Nandini. Wow. Nandini has given a compliment. Once again, give me that compliment. I want to see. Nandini has written a poetry. Oh, please. Please, once again, share it. I would like to read it out. Wow, Cardian, Sahana. Very good. Everyone. Wow, Chetra. Chetra, call everyone. I want to see everyone from your class. Call them. I want to see everyone, kids. Then I will really enjoy. Nandini, please share once again that message. Nandini, please. Nothing, also something. I want to see that what you have written. Nandini, sir, son is saying like, I don't want to come your earth because my copy is there. Oh, yay. Wow, Nandini. According to Nandini, Baba is another sun, the ultimate source of energy. Thank you, Nandini. Really awesome. Awesome blossom. That's really awesome. Thank you. Thank you. Thanks. Now, kids, see what other type of question they can give. See, the question can be like this. Question can be like this. Find out number of monochlorinated monochlorinated. Now in monochlorinated, one more thing is possible, structural as well as stereoisomers. So take care of that. They will write down here structural isomers only. If they are writing structural only, then it's very good. No need to worry. Structural isomers only. Otherwise, it will become lengthy if they are asking optical also. Find out number of monochlorinated compounds in the following. Gets C, CH4, C2H6, C3H8, C4H10, C5H12. Maximum this much they can ask. Maximum this much. So let me tell you the answers. For this it is 1. For this it is 1. For this it is 2. For this it is 4. For this it is 8. Now those who have studied isomerism, they know very well that butyl forms 4 monovalent radicals. This I taught you over there. C4H9 will have 4 monovalent radicals. Do you remember? Kids, do let me know. Do you remember this thing or not? And C5H11 will have 8 monovalent radicals. This thing, if you remember, then easily you can answer it. I want to see in the chat that yes. Everyone, just do let me know, kids. Do let me know, kids. You got it? Yes. Now, kids, if you remember this thing, you can easily answer that question. Now, let me tell you the mechanism. And once I'm going to tell you the mechanism, then definitely each and everything will become very easy. So are you ready for the mechanism? Everyone say you are ready. See the reaction and mechanism. Reaction and the mechanism. Suppose examiner has given you this question, CH3. Or simply if I say RH, he has given RH and he has reacted with Cl2H nu. How the reaction will proceed? First of all, let me tell you what else he can give you. When alkene reacts with chlorine or bromine or any. So let me write down alkane, that is RH, is reacting with any halogen, let us say Cl2. Now there are 2 ways in which it can react. The 2 ways are, one is photochemically. Another way is thermally. Now my dear students, in the examination, if you're not able to understand this photochemically and thermally, you won't be able to answer the question. Mark my words, kids. Mark my words, kids, you won't be able to answer the question if you're not able to remember these 2 things. So always try to put your hippocampus, this photochemically and thermally word. Now in photochemically, he can give you sunlight. Sometimes he will write diffuse sunlight. Some other time the examiner will give you UV rays. or some other time he can give you whatever he wants to give. H nu is equal to H nu. In thermally, always remember tofu C, TFC. This is very, very important. Now T stands for 200 degrees Celsius, C for Celsius, to 500 degrees Celsius. Now F for 4, 2 for 3, T for 3, F for 4, they are also in this range. So if you are getting confused, no problem. 300 degrees Celsius, 400 degrees Celsius, all they will work. If this much high temperature is given, then the two types of heat systems are there. One is the sunlight. If you want to dry your clothes, you will never use your gas. You require sunlight. If you want to cook your food, both of these two can be used. So thermally, photochemically, everyone say thermally, photochemically, thermally, photochemically. So two ways this reaction will proceed. Yes, reaction will take place. Reaction will take place. So whenever examiner is giving any of these two things, you have to proceed. One thing is clear. Now I'm going to start the reactions. I'm going to tell you the mechanism. Just see to it, everyone, that suppose if examiner has given you CH3, CH3, Cl2, H nu, how the reaction is going to proceed. Just see. The first step is the sunlight will come, and this first step is known as chain initiation. Everyone say along with me, chain initiation. Everyone say chain initiation. Chain initiation. In this step, free radicals are generated. There is birth of free radical. Birth of free radicals. You know, these free radicals are dangerous thing. Free radicals are getting generated, kids, right? Free radicals are generated. How the free radical will get generated? This chlorine and this chlorine, they are forming a non-polar bond. That means division of the electron is equal. So sunlight will give one electron to this chlorine and one electron to this chlorine. This is known as homolysis. Everyone say homolysis, homolysis. And this is fish hook arrow. What is? Sorry, fish hook arrow. It is represented by fish hook arrow. Now there is free radicals generation, 7 electrons in the valence shell. Now chlorine is in need of electrons. The free radical is generated. Now see, kids, after this step, chain propagation. Remember that, chain propagation. Chain propagation will take place in two sub-steps. Sub-step A, this is most important, sub-step A, and second one is sub-step B. This we will see on the second page, sub-step A and sub-step B, chain propagation. This is the main thing. So see to it, chain propagation. Now kids, this is the main step, chain propagation. Sub-step A. Which sub-step A? What is going to happen this sub-step A? Now if you remember this sub-step A, you can deal with all the questions and you can solve all the questions. Otherwise not, kids. Otherwise not. Now see, kids, that free radical, chlorine free radical, is having two possibilities. One possibility is that it can take away this H can go, or it can form a bond with this carbon. But remember that this chlorine, to form a bond over here, its activation energy is very high. EA is very high. So this step will not take place. This step will not take place. So chlorine will go along with hydrogen. This is a feasible. Its activation energy is less. So chlorine will form a bond with hydrogen. Its activation energy is low, and so this step is possible. Now see, it will be forming a free radical. Now see kids, alkyl free radical. This is main thing. Now kids, this is the point to be noted, my lord, everyone. This was having 8 electrons over here. Its octet was complete. It was with complete octet. Am I right, kids? It was with complete octet. Now it is having just 6 electrons only. Can you see 6 electrons only? Do you think it is stable? Not at all. It is highly unstable, kids. Got it? Highly unstable. Now tell me what I am going to write. I want to see the chat section from this step to this step, what I am supposed to write. Thank you, Dr. Tuvi. Do let me know. I am waiting for your response in the chat. What should I write over here? If I am telling you this much, what should I write over here? What I am supposed to write? It will take, it is 6 electrons only, Dishant, not, oh, 7. Yeah. You are right. Free radicals, so 7 electrons. Yes. 7 electrons only. 7 electrons only. Octet is incomplete, unstable. This will take place slowly or speedily. Break I will give after 20 minutes. After 20 minutes I will give break. Do let me know, it will take place slowly or speedily. Speedily or slowly? Definitely very slow, and slowest step is RDS. Slowest step. So it is a rate determining step, RDS. So one point to be noted, my lord, that rate of FRSR is directly proportional to what? Do let me know. Gets point to be noted, my lord. Rate of free radical substitution reaction is directly proportional to stability of alkyl free radical. Alkyl free radical. And if I ask about the free radical stability, how will you find out the alkyl free radical stability? Then the answer lies that free radical stability is like this. Yes, do let me know in the chat section if you remember free radical stability, kids. If you remember free radical stability, resonance stabilized is more stable. Resonance stabilized is more stable. After that 3 degree, after that 2 degree, after that 1 degree, and least is methyl free radical. Am I right, kids? Am I making sense or not, kids? This is the stability order. Am I making sense or not, kids? Do let me know, everyone, in the chat section. If you remember this, then only you are going to give the answers. Otherwise, you won't be able to answer the questions. Now kids, what is going to happen in chain propagation B substep? B substep of chain propagation, that alkyl free radical, now it will break chlorine. Initially the chlorine was broken by sunlight, now it will be broken by this alkyl free radical, and that's why once the reaction has been started, even the sunlight source or the heat source, if it is removed, then also the reaction will move for some time. It's not like that reaction will get stopped immediately. Now once it is going to do, you will get main product kids. You will get what? You will get main product. Now kids, examiner will ask that main product formation is taking place in last step, that is termination, or main product is getting formed in propagation also. What should you write kids? What will you write kids? So main product got formed in propagation, and that will also get formed in termination also. See, now the third step is termination, chain termination. Everyone see, chain termination. Now in this, the one who has come to this world, it has to go back. So most of the free radicals will get consumed. Most of the kids, do let me know, most of the free radicals will get consumed, How they are going to get consumed? See kids, one possibility is that chlorine can combine with chlorine to form Cl2. Another possibility is that chlorine can combine with ethyl free radical to give Cl, CH2, CH3. Third possibility is that ethyl free radical can combine with ethyl free radical. If you remember this thing I taught you, that is disproportionation. Do you remember kids? Disproportionation. It will give ethene in traces along with ethane. Is it clear to all of you kids? So main product is getting formed there also, main product is getting formed here also. So main product is getting formed at two places. I hope it is clear. If it is clear, I want to see green hearts in the chat section. Kids, everyone, I want to see green hearts. Let me see what people are writing. People, you are enjoying or not? People, you are enjoying or not? Hey kids, do let me know and hit the like button kids. Just after 15 minutes you will get break. Hey everyone, all my dear students, do let me know. Fast. I want to see chat running speedily. I want to see this chat running very speedily kids. Now, with this, I have to go back. Somebody is calling me. See who is calling me, kids. Somebody is calling me. The Kolbe is calling me. See, kids, why? Why Kolbe is calling me? See, kids. Hey, my dear Kolbe, why are you calling me? Now, Kolbe is scolding me, kids. This Kolbe is scolding me. Ask me why Kolbe is scolding. Kolbe is asking, hey, what will happen HSP by chance this year also they are going to give question as last year they did for the physics. You know, the physics paper was really very tough last year. If they are going to do the same thing but this time with chemistry, they will ask one question. One question. Butane is in the sunlight, butane will break. If you're giving, you know, later on I will teach you pyrolysis. Very good question you have asked. What about butane? See kids, butane there will be breaking of higher chain to lower chain. So butane will not get formed. Butane will not get formed. Right, Shukant? That high temperature pyrolysis, breaking of higher chain into lower chains, so no butane. Now this Kolbe is asking one thing, what will be the minor product or the each and every product? Write down. If the examiner is asking this Kolbe electrolysis, if examiner has asked even that minute traces product, that also write down. Suppose he has given question like this, CH3 CH2 COOK aqueous current. Now we know the products. We know the products. How many products we know? We know that butane will get formed at anode, right kids? Write down all those products which you know. Plus 2 moles of carbon dioxide we will get, plus twice of KOH in the solution we will get, and at cathode we will get hydrogen gas, H2 gas, right? This much we know very well. This much we know very well. Now in traces kids, remember that in traces, see, this is very important, that CH3 CH2 C double bond O free radical was formed or not? Tell me, this free radical was formed before release of carbon dioxide. This free radical was formed, and once carbon dioxide was released, we have got this free radical formation also. Before release of carbon dioxide, before elimination of CO2, and this is after elimination of CO2. Am I right kids? If now both of these two free radicals are getting combined, what you will get kids? Both of these two free radicals are combining, what you will get? We will get ester as the product. I was just waiting for the thing that I have missed something. At that time I was just reminding about what I have left. So ester in traces. In traces means in very small amount. See kids, Baba is not only thinking about future or present tense. Baba is always thinking about past also. Is there anything Baba missed? Is there anything which is missed by Baba? So I got this thing in my brain that yes, if examiner by chance is giving you tough question, then definitely he might be interested in this one. He might be interested in this one, kids. Are you getting my point? everyone. This one is really the most important thing which can be asked by examiner. This is the most important thing, kids. Thank you, Dishant. Thank you. Thank you. Now see, kids. Let me go back. Let me go back where I was. Chain termination we have done. Now, after this, the examiner will ask question. See that this is CH3, CH3, CH3. What is its name? Definitely its name is tertiary butane. Am I right, kids? Now, the question is, if we are dealing with its chlorination, Cl2H nu, we will get two types of products. What are these? One is CH3, CH, CH2, CH3. That 1 degree carbon is holding chlorine. You know that it is having primary, all they are same, and this is tertiary we are having. If you see, this is tertiary. So in primary I have added, suppose this is a X product. Now another one will be tertiary one, CH3. Chlorine is attached on tertiary carbon. It should be like this. Suppose if I say this is Y. Now, my dear students, my question is, which one is major? Write down in the chat section. Just after 6-7 minutes, I will give the break, right? Break will be just after 6 to 7 minutes. Now, do let me know. If I ask which one is major, that is my question to public. I want to see which one is the major out of these two. If you are able to answer it, definitely something for very good kids. X is being major, Y is being major. Yeah, break just after 5 minutes, kids. Just after 5 minutes. Let me explain this. Just after 5 minutes, I will give break. Now, kids, let me explain this. Then I will give break. Whether it is going to take 7 minutes or 8 minutes. Everyone has written Y is major. Kids, let me tell you, X is major. Now what you will say, kids? That how so? This is minor. This is minor, that is major. Everyone got failed or not? Tell me, each and every one of you got failed or not? First of all, do let me know that each and every one got failed or not. Ayyo, Ranga Swami. Now you must be thinking, what you have written, sir? Will you prove it? How will you prove it? Let's see, I am going to prove it. For this is, I am over here. Ready, kids? See, everyone see this table. This table is being experimentally determined. Experimentally determined table. Okay? Experimentally determined table. At that time I said chlorine versus bromine, selectivity and reactivity. Do you remember? selectivity versus reactivity. Do you remember, kids? Say yes or no. Always participate in the chat. Now, primary, secondary, and tertiary removal of hydrogens. It's primary removal, secondary is removal, and tertiary is removal. So its liking is 1 times 1, 1, 3.8. It is 82 times. This is 5 times, and this is 1600 times more. See the difference. And you have to cram it. Cramming is required. Cram it. Just keep it in your hippocampus stable. Put this data in your hippocampus, medulla oblongata, hippocampus. Now let's see. I'm going to explain that question's answer. Ready, everyone? Show me some fire that if you're ready. If you're ready, I want to see some fire in the chat section. Now this table should be there in your brain. So see the difference, how much it is selective for 2 degree and 3 degree, how many times. So see kids, I'm writing that question once again. And if I write down that question, just see kids, this question is having how many 1 degree hydrogens? Do let me know in the chat. It is having 1 degree carbon, 1 degree carbon, 1 degree. So 9 primary hydrogens I am having, 1 degree hydrogens. Primary, that is 1 degree hydrogens, I am having 9. And tertiary, I am having just 1. This point is clear to each and every one. Tertiary, I am having just 1. Is it clear, kids? Till now, is it clear that primary hydrogens I am having 9 and tertiary I am just having 1. Now see, I formed this product Cl2H nu. This I said to be the major. I told you this one where the primary carbon chlorine was attached. I said this is major. Let's see, let's calculate its percentage of this. How to find out percentage? That is important. I said this is X. I said this was X. I called it X. So let me calculate percentage of X. Let me calculate percentage of X. Am I right? Oh, what's going on? Let me calculate percentage of X. So draw one line, multiply by 100. This is the way we were calculating percentage, right? Now, in the numerator, just write down where this chlorine is attached. This chlorine is attached on 1 degree carbon. How many hydrogens are there in the reactant? Whenever you see the reactivity, the percentage, you have to see the reactant. How many 1 degree hydrogens are there? 9. We are having 9 1 degree hydrogen. Why we are saying about 1 degree? Because we are going to calculate the percentage of this where chlorine is attached to 1 degree. So 9, and what is its reactivity? Just see the table. Its reactivity was 1. For 1 degree it was 1. So I will multiply with 1. The same thing I will write down over here. Now I will put sign of plus. Now see how many tertiary hydrogens I am having, just 1. But its reactivity was how much? Tertiary hydrogens reactivity was how much? Tertiary hydrogens reactivity for chlorine was 5 times more. 5 times more. So I will write down 5. So how much I have got? 9 upon 9 plus 5 into 100. So how much it is? 9 upon 14 into 100. Do anyone the calculation and do let me know how much it is coming. 900 upon 14. 14 पंचे 90. 14 पंचे 90. 10. 14 पंचे 90 means 55%. I think near about 55. No. 4 84 is more than 60%. 4 84. 4 84 and 16. So it's more than 60%. Just see, just check it out. Approximately 64%. Approximately 64%. Kids, you got it. 64. Now I'm going to give the break, kids. Have you seen, kids? Everyone got failed for this. Now, the same thing it would happened with the bromination. Just see, if same question would have been asked for bromination, then see, you will be absolutely correct. See, the same question would have been asked for bromination. After this, I will give you a break. If the same question would have been asked for bromination, just see to it. Everyone just see to it. Your answer would have been 100% correct. Bromination, Br2, H nu, Br2, H nu. Now, one product I will get this one. I can simply write it as minor because bromination is selective, and if somebody is selective, it will not count the number. Its selection will be mainly for this one. This one will be absolutely major one. Now if you want to calculate, you can calculate. See, its percentage. If I want to calculate its percentage, only one, but its reactivity is 82 times. 82 upon 1 into 82 plus 9 into 1. 9 into 1 into 100. Just to let me know. 82 upon, it's coming out 82 upon 82 plus 9. 91 into 100. Do let me know how much it is coming out. Now, after this, I will give break. Do let me know how much it is coming, kids. This is the difference between reactivity and selectivity. This is the difference, kids. This is the main difference between reactivity and selectivity, and that's why I'm telling you this holds a hell lot of weightage, kids. This holds a hell lot of weightage. Do let me know, kids, everyone, how much it is coming out. How much it is coming out, kids? Kids, that's not 2 degrees. 1600. Oh, tertiary. I have written wrong, kids. Oh my God. It's not secondary, kids. It's wrong. The data I've written for secondary, it's for tertiary. Thank you, kids. Thank you. The data I have written for secondary. See. 1 into 1600. Oh my God. And upon 1600 plus 9 into 100. So it will come out 1600 upon 1609 into 100. So it is coming out approximately 99%. Oh, great, kids, great. See, it's coming out 99%. So this is the meaning of selectivity, kids. This means selectivity. You got the meaning of selectivity now. Why I was telling you selectivity means a lot. This is the meaning of selectivity. I hope that everyone is able to understand the meaning of selectivity, kids. Clear, kids? Clear? Now this one is major. Got it, kids? I want to see green hearts if everyone is able to understand this one, kids. Do let me know, kids. 99.4%. Wow, great. Now everyone is able to understand the what's the meaning of selectivity and what's the meaning of reactivity, kids. Kids, fast. Then I'm going to give you one break. Everyone. Got it. So let's meet. It's a dinner break. Let's meet at 8:50. Dinner break. Let's meet at 8:50, right, kids? Kids, do let me know. Are you getting what I'm saying? Come with full of ATPs. Everyone, it's my humble request. Right, kids? Will you follow it? What I said? What I'm asking? Will you do that? And everyone, will you come with full on Josh? Make a promise with the fire and hit the chat. In the chat, the like buttons, smash the like button. Everyone, I want to see fire in the chat and smash the like button. If you have not done till now, if you're not done yet, I want that everyone smash it out. Thank you, Dishant. See, Dishant has written. Okay, we'll meet you very soon at 8:50, right? Okay. Welcome once again, all my dear students. Just to let me know, am I audible and visible to all of you? Are you back? Let me check it out. If yes, if everyone is back, yes, full on green, green leaves, green hearts, whatever green is there, everything should be green in the chat. The chat should be with full on green. Okay, it's very hot over here, so let me move this. My instruments, do let me know. Audibility is okay now. I was just going through. It was a little bit low, kids. What I've seen that it was a little bit low, but now just check it out. Now is it okay, kids? Do let me know in the chats that am I perfectly audible and visible on time? Yeah, that consistency and punctuality, that is going to change the competition's flavor. That is going to change your life also, kids. So we should be punctual if we have given time. If you can't be punctual, no need to give the time. If you have given time to somebody, that time means a lot, kids. Now, just to let me know that rising star, do let me know. Sahana, do let me know. Its voice is clear now, just to let me know. Am I perfectly audible and visible? Now, my dear students, by chance, if I not able to complete hydrocarbon, then I will take part 2, but I'm not going anywhere. I will try my level best, but hydrocarbon is so wide that in hydrocarbon alkyl halide, half of the alkyl halide is going to get completed. Some part of alcohol and some part of aldehyde and ketones will get involved over here. So it's not easy. And I'm not going to skip even a single thing. My dear students, mark my words. I'm categorically telling you this particular point that Baba is not going to leave even a single point, not the mechanism. Whatever is required for your examination, I will tell you each and everything. That's my promise. So kids, thank you, Somaya. Thank you, Somaya. Kids, I will go with each and everything. I'm not going to leave even a single thing, right? Okay. So ready, let's it go. Now, if everyone is there, I want to see green hearts along with some fire. If I'm perfectly audible and visible for this green signal, and if you're ready for that, I want to see the fire in the chat section. Fire in the chat section. Now, kids, FR, SR, I have told you. Now, the second thing I would like to say, if you are going to increase the temperature, right now I was telling you 300 to 500 degrees Celsius. Now, if the temperature is ranging from 500 to 700, if the temperature, thank you. Now, see kids, if temperature ranges from 500 to 700 degrees Celsius, then what is going to happen? Let's see. Now, the thing is that if temperature is ranging from 500 to 7 degrees Celsius, then what is going to happen? Then one thing will take place, and its name is very dangerous: pyrolysis. Pyrolysis will take place, kids. What will take place? Pyrolysis. So remember, most of the time we are not able to understand what does it mean, pyrolysis. What does it mean? So pyrolysis means breaking down of higher hydrocarbon, higher hydrocarbon into lower one, into lower one, into lower hydrocarbon, into lower hydrocarbon, lower hydrocarbon. Now, my dear students, in the previous year examinations, if I talk about, they have not given so many questions, but if they are going to do so, then this question will be very, very tough. This will become very, very tough. Now see, why this question will become very tough. First of all, let me tell you, here the temperature range is from, remember that, FSC. What do you mean by FSC? I'm not writing anything in degrees Celsius. 500 to 700 degrees Celsius. 700 degrees Celsius. This much very, very high temperature. So this much of high temperature will not only break carbon to hydrogen bonds, it will break carbon-carbon bond also. It is going to break both the two things. Along with carbon, hydrogen, it is going to break carbon-carbon bond also. So it is also known as, sometimes in place of pyrolysis, we call it cracking. What do we call it? Cracking, kids. What do we call it? Cracking. Cracking also the word. Now let's see what do you mean by pyrolysis or cracking. Just see and how to answer the questions. Pyrolysis or cracking. Suppose they have given hexane. They have given hexane C6H14. Now if you're giving this much of temperature, 700 degrees Celsius, what will you get? What things you can get? See, if I write down hexene, say 6H12, then what is missing? Hydrogen gas is missing. I can write like this. Now suppose if I'm writing one is pentene, C5H10. Now can you please help me out? What is missing? One carbon is missing, and how many hydrogens are missing? 4 hydrogens are missing. Can you see? If I subtract this C5H10, then 1 carbon and 4 hydrogens, then let me know in the chat section what I will write down here. I will write down here CH4. Kids, are you there? Let me see that everyone is there. Let me check it out. That is everyone over there, kids. Why the likes are less, kids? Hit the like button. Everyone smash it out. Now see, kids, how to form the product. Now suppose if I'm writing here C4H8, then what is missing? 2 carbons and how many hydrogens? 6. So I will write down C2H6. Now suppose if I'm writing here propene C3H6, what is missing, kids? 3 carbons are missing, 3. And how many hydrogens? H8. So we are getting alkene, we are getting alkane. These are the products. Any lower product you can frame out. Low voice is there. Let me check it out. Now see, kids, now let me see. Just wait. Let me check it out, kids. Hello. Now check, kids. Now check, kids. Everyone now check it out. Hello. Now check it out. Now somebody has written low voice. Now check it out. Now, is it okay now? Kids, do let me know. Now the volume is okay. Now the voice is okay, kids. Just to let me know, everyone in the chat section. Now is it okay or not, kids? Absolutely clear, is it? Now it's better than earlier or it's fantastic, fit and fine? It's better than earlier or it's fully fine? Just to let me know, kids. It's fully fine or better than earlier? Now, okay, okay. Now, see, kids, everyone. So, this is pyrolysis. If you're giving this much high temperature, 700 degrees Celsius. Now, I think pyrolysis is clear to all of you. These are being alkane and then, like, see the combination should be very perfect, right? Now, why I'm going to tell you pyrolysis? After pyrolysis, if I say that if they are giving question on nitration, just see, if they're going to give question based on nitration, so suppose once they have given the question I will tell you, the butane, I took butane, just see to it, my dear students. If I react with HNO3, then remember that no reaction will happen. Why, kids? Because it would like to donate its proton, but alkane says, I can't accept your proton. So acid-base neutralization can't take place. That means ionic mechanism is not possible. Remember that ionic mechanism is not possible at all. Not possible, kids. Not possible. Ionic mechanism is not possible. Now, what is possible? Only free radical substitution reaction is possible. FRSR is possible. So, for FRSR, we have to provide temperature, high temperature. Suppose they have provide 600 to 700 degrees Celsius temperature. Then HNO3 will break. Not only HNO3 will break, or this alkane will also break. Number of things are possible. HNO3 will break. Carbon to carbon bond will break. Carbon to hydrogen bond will break. Three things are possible, my dear students. Remember that HNO3 will break. Carbon to carbon bond will break. Carbon to hydrogen bonds will break. Three possibilities are there. Total three possibilities are there, my dear students. Are you getting my point, what I am talking about? Now let me break these three things one by one. So if I say, if I remove this 1 degree hydrogen, then from this what I will get, what I'll be getting, it's definitely I will be getting this free radical, primary free radical. Yes sir, we will get primary free radical for sure. If I break this bond, why? Temperature is going to break all the bonds. So all the possibilities I'm just writing, then I'll be getting this 2 degree free radical, my dear students. Now if carbon to carbon bond is breaking, then two possibilities are there, that carbon to carbon bond can break from here and carbon to carbon bond can also break from here. Two possibilities are there, because this much high temperature is going to do pyrolysis also. You were just trying to break down HNO3, but that temperature is saying I will break carbon to carbon bond also. My dear friends, just see, these many bonds are going to break, so you will get this free radical also, and you will get, if it is breaking from here, then you will get this free radical also, and you will be getting this free radical also. My dear students, these are the free radicals, these are the free radicals, number of free radicals, alkyl free radicals. But of all these free radicals, which free radical is most stable? If I give the name. If I say this is A free radical, this is being B free radical. If I say at the same time this is being C, this is being D, and this is being the E free radical. Out of all these free radicals, I would like to see in the chat section, what do you say that which one is most stable? Then the answer comes out, this 2-degree free radical is most stable because from this side is giving electron this side. Now, if I say hyperconjugation, these are 3 alpha hydrogens, and they are being 2 alpha hydrogen atoms. So total 5 alpha hydrogen atoms are there. So it is stabilized by hyperconjugation, as well as it is 2-degree free radicals. So it is stabilized by inductive effect. Among all the free radicals, this free radical is found to be most stable. Am I right, kids? Am I making sense? This is most stable free radical, kids. Do let me know. Whatever I'm saying, you are able to understand. So this is all about. So what was the question? The question asked by this, which is the major product? Which is the major product? So this is most stable free radical. Now let's see the story of HNO3. What is going to happen with HNO3? HNO3 will break like this. NO2, OH. So HNO3 will break like this, my dear students, as a free radical from here. So it will give NO2 free radical and OH free radical. So whatever the carbon free radical has been formed, NO2 will also go and attack over there, and OH will also go and attack over there. Now you know the less electronegativity difference, if it is there, that bond will be more stable. So carbon electronegativity is 2.5, nitrogen is 3, oxygen is 3.5. So who is nearest to the carbon? Do let me know in the chat section. Whose electronegativity is nearest to the carbon? So definitely NO2 will attack, and NO2 will attack on this free radical, and that will be your major product. So question asked was this. Only one question till now they have asked. Till now they have asked only one question on this, that what will be the major product? So this was the question. Find out or write down the major product. Write down the major product of which reaction. Reaction was asked like this. They have given out butane, CH4, CH2, CH2, CH3 plus concentrated HNO3 and 650 degrees Celsius was the temperature. So major product answer is that free radical will combine with the most stable free radical. So CH3, CH, NO2, CH2, CH3. 2-nitrobutane is the correct answer. I hope that everyone got it. 2-nitrobutane is the answer. If it is clear, do let me know in the chat section that yes, sir, we got it. Now, my dear students, what to say? That everyone just write down in the chat section that you are able to understand or not. You are chatting with yourself only. Give importance to your Baba HSP, not then give importance to your this chemistry. Everyone, 2-nitrobutane is the answer. Do let me know in the chat section, everyone. Now, after this, let me tell you the next important reaction, that is controlled oxidation. controlled oxidation. What I'm saying, it's controlled oxidation. This one is definitely the most important one, because this is a painful thing, because number of times you always skip it. So come on, man. Hey, come on, man. Nandini, why are you leaving? Nandini, why are you going? Don't do that. You're not supposed to do that. Don't go, please. Now, controlled oxidation. Suppose if I take CH3, what do you call it? Ethane. Now, if I do the controlled oxidation, three things always come to my brain. Three things. What are these three things? Just see. First, on reaction with copper and heat, very high temperature, then molybdenum oxide, MO2O3, then heat, and then manganese acetate, CH3, COO, whole twice, manganese, and then heat. Remember that in the sequence order. Come on, man, acetate. This is the trick. Come on. Now see. Here I will get alcohol. Same carbons, alcohol, C2H5OH. Here I will get same carbon, aldehyde. That's it. And here I will get same carbons, acid. That's it. Is it clear to all of you? Now, one more reaction. Three reactions I have told you. There is one more reaction, that is the fourth, and this is the very special reaction. The tertiary butane, when reacts with KMnO4, acidic medium, it will give tertiary butyl alcohol. You must have seen in your NCERT. Just remember this. This is one special reaction. Just keep it in your brain, the special reaction. Will you, kids? Do let me know. Will you be able to keep it? Everyone, do let me know, kids. Will you be able to keep it? This is special reaction. Rest of the things, whatever the alkanes are there, alcohol, aldehyde, and acid. Alcohol, aldehyde, and acid. Lakshmi, Mick, MK, very good. That's really awesome. That's really awesome. Now, see, kids, everyone. After this reaction, I would like to go with aromatization. Have you ever heard this word? Aromatization. Two reactions are there in this category, of aromatization. Let's see what are these two reactions. Everyone, aromatization. When you take N-hexane, N-hexane means straight hexane, then what is the aromatic with 6 carbons? So definitely with 6 carbons, aromatic is benzene. It's natural and it's easy also. If you take N-heptane, what is the aromatic thing with 7 carbons? So don't make with 7 carbons, just make benzene only and put CH3 over there. Now, these are aromatic. Which reagent you will take? That is important. Which reagent you are going to take, that holds a whole lot of weightage. So remember that any of the 3 oxides you can take, any of the 3 oxides. Now, what is that? One is to, MO2O3 you can take, or V2O5 you can take, or chromium oxide could be taken, Cr2O3. Either of the 3 reagents you can take, you will get this answer. So do remember these 2 reactions. They are very, very important. They hold a hell lot of weightage. Now, last but not the least, that is isomerization. How I can forget about isomerization? Do you remember, kids, what we need for isomerization? What we require for isomerization? So remember that isomerization will take place. Suppose they have given N-hexane and they have given reagent like anhydrous AlCl3. If they have written anhydrous AlCl3. Now kids, it's very simple that you can frame out less than one carbon. So if I say there are 6 carbons, what should be less than 6 carbons? 5 carbons. 1, 2, 3, 4, 5. So put methyl over here. At second position, you can put methyl. Let me write down the counting. 1, 2, 3, 4, 5. Or what is possible? You can do one more thing. 1, 2, 3, 4, 5. Take 5 carbons and put methyl over here. At which position? 1, 2, 3, 4, 5. So these are having the same molecular formula, so they are not going to make any difference. So now you can frame out CH, CH2, CH2, CH3, CH3, CH2, CH, CH2, CH3. Is it clear? 2-methylpentane, 3-methylpentane, these are the isomers. So I have completed alkane, but one reaction in alkane is left. What is that? We missed one reaction in alkane. That was during preparation of alkane. See, during preparation of alkane, one reaction is left. Let me tell you which reaction is left during preparation of alkane. Just see to it. Let me tell you, let me add to your memories. One reaction we have done, this one. This one we have done. If you remember, if you want to get the rank, you have to remember the things. Just note down this thing. Yeah. Now kids, if I'm going to react this Ri with 2 hydrogens, so same thing, if I react RCl with hydrogens in presence of zinc and HCl, then also I will get RH and ZnCl2. That's it. I haven't actually missed anything, but let me tell you, this is one simple reaction and this is another one simple reaction. I hope that everyone is going to recall it. Kids, yes, Chaitanya, you are right. Now alkane got completed. Now, how many of you are ready for alkene preparation? Because alkene preparation will require knowledge of alkyl halide, or if you're not having any knowledge of alkyl halide, I will tell you each and everything over here, because we are dealing with hydrocarbons. So you are kiddo kids, small kids. So alkyl halide will come in class 12th. So I'm going to tell you that whatever the portion of alkyl halide is involved over here, later on that is going to give you benefit when you study haloalkanes, haloarenes. So are you ready, kids? I want to see the Josh. I can't see the Josh. Josh is missing, kids. Where is the Josh? Everyone show me fire in the chat section, then only I am going to deal with alkane preparation, otherwise I won't. See, let me see the Josh in the chat section. Alkene. I'm going to start with alkene, kids. Alkane got completed, done and dusted. We are going to start with alkene. Now, how many of you are ready? That I want to see, kids. Otherwise, we are not going to start alkene. Alkene unsaturated. Alkenes means unsaturated, kids. Alkenes, if I talk about alkenes, alkene simply means unsaturated. So unsaturated means there must be carbon-carbon double bond. Carbon-carbon double bond. Out of these two bonds, one is sigma and another one must be pi bond. One is sigma, another one must be pi. Now, we are going to deal with preparation of alkene. This will take some time. This will need your brain also. Brain will also be required. So once who are really having that dedication level, then tell me that yes, you are ready. Otherwise, not required, kids. It's not necessary that we should deal with alkene. So it will require some brain, kids. If you're really ready, then we are going to start with alkenes. So in alkene, first we will start with elimination reactions. See the notes. Very good, rising star. That's really awesome. Now, elimination reactions will convert sp3 hybridized carbon to sp2, or sp3 can directly get converted to sp. Degree of unsaturation will increase. That means single bond can convert into double bond, or single bond can get converted into triple bond, right kids? Single bond can convert into double bond, or single bond can convert into triple bond. That is, degree of unsaturation will increase. Now kids, what I am going to teach over here, I will teach dehydrohalogenation, dehalogenation and dehydration. How many things we are going to deal with in this? Tell me kids, how many things? Dehydrohalogenation one thing, dehalogenation second thing, and dehydration third thing. If you're really ready for these three things, do let me know. Now dehydrohalogenation means loss of HX. What I'm saying kids? Loss of HX. HX is going to eliminate out. Dehalogenation means loss of X2. X2 will eliminate out. And here water will eliminate out. These are the meanings of these terms. Loss of HX, loss of X2, loss of water. So we are going to start with dehydrohalogenation. Dehydrohalogenation. Now see, this question will be the rank deciding question. I'm going to start with rank deciding question. I'm not going to start with simple questions, because simple questions, I will deal with simple questions also. First, let me explain the mechanism. Now, while seeing this question, what are you thinking? Sir, what are you doing? Why you are giving such tough questions? Sir, please, first teach us. Are you ready? Wow, Sivash, Sanjay, that's really awesome. Should I tell you first, then I am going to deal with the questions? Should I tell you the mechanism first, kids? Everyone, do you want that Baba should tell you the mechanism first? Everyone, just do let me know. Now see kids, see that elimination follows two mechanisms. Elimination, that is dehydrohalogenation. Elimination by dehydrohalogenation. Dehydrohalogenation. One is alpha, another one is beta mechanism. What are the two mechanisms? Alpha and beta. First one is alpha. It is also known as 1, 1. And second one is beta. It is also known as beta elimination. Is also known as 1, 2 elimination. Let's see what is the difference in between these two. There is just one example of alpha elimination. Rest of beta we'll see in detail. This is, we are going to see in detail, and there is alpha eliminations, only one example. Let's see, if I say there is chloroform CHCl3, and if I bring some strong base like KOH, alcoholic, and heat, you know very well that if I say KOH alcoholic, then what is going to happen? This OH negative will take away this proton, my dear students. Now, OH negative always it is in need of taking proton. But why this compound is giving that proton? That is the $1,000,000 question. Then the answer lies kids that if it is gaining negative charge, it will be stabilized by back bonding. What is that? So, what is back bonding? See, once carbon is having negative charge, at the same time, carbon is having 8 electrons. What's the problem with the carbon, this carbon? That it want to donate electrons so that its charge should get decreased. That is, stability is directly proportional or inversely proportional. So, stability of any intermediate is inversely proportional to the charge. If charge is less, stability will be more, my dear students. Now, this carbon will donate its lone pair to its 3D. 3p is having electron, but 3d is vacant. 3d is empty. 3d is empty, so delocalization will take place, and due to this delocalization, the lone pair will go to this. So steric number will be just 3 sigma bonds, no lone pair. So sp2 hybridized, and if the hybridization is getting changed, its shape will be trigonal planar, not like ammonia, right? Not like ammonia. Now, ultimately it is having negative charge, so K plus will come to C negative, and it will say, hey, I need your chloride. So K plus will show some interest in taking away this chloride along with electron. Now it will form CCl2. CCl2 is known as dichlorocarbene. Dichlorocarbene. And now, my dear student, dichlorocarbene is electrophile. It is just having 6 electrons in the valence shell with neutral, no charge. It is being neutral, highly unstable species. The kids, those who know very well that it is responsible for 2 named reactions. One is being a Riemann-Tiemann reaction, and another one is carbalamin reaction. Later on, when I will deal with name reactions, I will let you know dichlorocarbene is the main intermediate, and that is singlet one. Singlet one is more stable, and it is only the attacking agent. You will say, sir, how? But later on, I will let you know when we will deal with carbalamin and Riemann-Tiemann reaction. Till now, whatever we have studied, why it is known as alpha elimination? Because same carbon has lost hydrogen and same carbon has lost halogen. The halogen and hydrogen that has gone from the same carbon, and that's why it is known as alpha elimination. Generally, it doesn't happen. This happens only with this compound for your syllabus. Otherwise, reactions, majority of the reaction, or 99%, 99.9% reactions which are in your syllabus, they belong to beta elimination. Now see how beta elimination will take place. So one carbon is having hydrogen over here and the halogen over here. Whatever is attached doesn't matter. Maximum reaction falls in this. This is alpha carbon, this is beta carbon. Halogen will go from here. K plus will take this halide. It will develop partial positive charge, and OH negative will take away this proton. It will develop negative charge, and happy ending will take place like this. This KX, this water. So beta elimination or 1,2 elimination. So majority of the reaction will fall under this category. Till now, if everything is clear, I want to see the green symbol in the chat section. Everyone just do let me know that till now whatever I told you about alpha elimination and beta elimination, do let me know, is it clear or not, kids? Everyone just do let me know. And likes, can you increase likes from 186 to 200? Can I see session duration? I will not take it for long, kids. I think it's 1 hour more, kids, because revision is also most important. One more hour. Whatever is completed in 1 more hour, we will go with that much, right, kids? Whatever is getting completed in 1 more hour, we will complete that much, kids, right? Later on, I will complete in the second session of hydrocarbon. But try to understand each and everything in detail, in depth, right, kids? Right? Jayalakshmi, welcome. Now see, beta elimination. Beta elimination is of 2 types. Beta elimination is how many times, kids? Write down in the chat section. If I say beta elimination, it is of how many types? It is of 2 types. One is E2, another one is E1. One is E2, another one is E1. Now, what is the difference between E2 and E1, kids? Remember that wherever 2 is written, that means it follows second order kinetics. It follows second order kinetics. What is the meaning of second order kinetics? That means that the rate of reaction, if I say R is equal to rate of reaction, is directly proportional to concentration of reactant as well as concentration of base. That R is the rate of reaction, K is constant. So I will write down R X, or whatever the substrate is there, concentration. This is indicating active mass. For dilute solution, we will take concentration substrate and the concentration of base. It is directly proportional to both. So if I say its power is 1, its power is 1, 1 plus 1 is 2. This is the rate of reaction and this is the rate constant, or I can say velocity constant, or I can say specific reaction rate. Remember that this reaction takes place in a single step. It is elementary reaction. What I'm saying, this reaction is elementary reaction. Elementary reaction means will take place in single step. Will take place in single step. Will take place in a single step, kids. What does it mean in a single step? It is going to take place. That means without intermediate formation. Without intermediate formation. Remember that, without intermediate formation. And if no intermediate formation is going to take place, that means no rearrangement can take place. No ring expansion, no hydride, no methyl shift. Kids, are you getting my point? No methyl shift, nothing will take place. Now, if I talk about even reaction, that means here R, that rate is equal to K, and it is dependent on the substrate, but the rate doesn't depend on the concentration of base. That means base is powerless. Whether you increase the concentration of base or decrease the concentration of base, there will be no change in the rate. Now remember that anything to take place in single step. This is taking place in single step. That means strong base will be required. Strong base will be required. Then only that will do the reaction in single step. Here this is taking place more than one step. It's a complex reaction. Why and how I can say it's a complex reaction? Because the base, it's not responsible for changing the rate. That means it is not involved in the rate determining step. And if base is not involved in the rate determining step, then definitely reaction will be more than one step. And if it is more than single step, it is a complex reaction. So complex reaction, what I'm saying, it's a complex reaction and will take place in more than one step. Will take place in multi steps. Multi means more than one steps, and will proceed with intermediate formation. Will proceed with what, kids? Intermediate formation. That means once the intermediate is getting formed, rate of reaction will be directly proportional to stability of that intermediate. Am I right, kids? One more thing is there, that if intermediate formation is taking place, that means ring expansion, hydride shift, methyl shift, all these are known as rearrangements. Rearrangement may take place. It's not compulsory. If in the starting only the intermediate is stable, no intermediate is stable, but comparatively, that I mean once the intermediate has been formed and by shifting it is not becoming more stable, then will not take place. So rearrangement may take place. What I'm saying? Rearrangement may take place. What I'm saying, kids? Rearrangement may take place. May take place. Somebody has written likes got, yeah, this time it crossed 200. Chaitanya, let me check it out. It has been crossed or not. It's been crossed 190. Chaitanya, it's 190. It's not 200. Now, kids, whatever I have written on the board, is it visible to all of you or not? Do let me know. Is it visible to all of you or not, kids? Are you able to understand everything, whatever I have written? So, I'm going to, let me have a sip of water, kids. Can I? Everyone, keep yourself hydrated. That is much more important. Keep yourself hydrated. Everyone, keep yourself hydrated. Now, kids, ready for everyone, ready for E2. I'm going to start with E2. Oh, once again, we have got same question, but first it's a time to start with E2. Let me tell you how to see the E2. Otherwise, you won't be able to do the question. Let's see E2. First, I would like to go with the example of NCERT, right? NCERT example, I would like to go with NCERT example. Now, NCERT example, let me see. I have taken the pic, whether it is there with me or not. See. Yes, I'm having this example. Can you see it? Is it visible? Dehydrohalogenation, how much hard work I'm doing for you. Can you see the reaction? Is the reaction visible to all of you kids? Simple class 11th reaction, alpha beta, alpha beta. They have removed hydrogen from here and halogen from here. They got alkene. Kids, can you see? Is it visible to all of you? Now, this is class 11th reaction. And now let me show you class 12th reaction. If you see, this is given in haloalkanes, haloarenes. I will write down by myself, but you see that this is 2-bromo-pentane. It has given 81% pentoene and it has given 19% pentoene. Alexander Jetsev, also known as or pronounced as Sedgev. So this is the time we are going to see Hoffman product, Sedgev product. It's very blur, I can say. It's not clearly visible, but don't worry. It's given in your NCERT. That I wanted to tell you. Now I'm going to explain. Now I'm going to explain each and everything from my side, kids. Ready? So, let's see. The simple reaction of class 12th, which is given in class 12th. Dehydrohalogenation. Dehydrohalogenation. Each reaction is important, kids. If I write down here CH3, CH2, CH, CH3, and here I have written X, that is halogen. Remember that this X can be either chlorine, bromine, or iodine, but this should not be fluorine. If it would have been fluorine, then the scene will get changed. Reaction will take place. I'm not saying reaction will not take place. It will take place. What product will be? The ratio of the product, the percentage of the product will get changed, right? Now see, kids, this is halogen. And the halogen attached to the carbon is known as alpha carbon. Remember, the carbon which is attached with halogen alpha, and the another one is known as beta. This is also beta, and this one is also beta. In the right also beta, in the left also beta. This is my right, this is my left, somebody on this side, somebody on that side. Are you getting my point? Now, halogen will go from here, hydrogen will go from beta. Beta, two types of products you will get. You will get two types of products. What are these two products? When you react with alcoholic KOH, either you can use KOH alcoholic and heat, it is a strong base, or you can take NaNH2, heat, it is also a strong base. Either of these two things you can take, then you will get products like this. One product will be CH3, CH, double bond CH, CH3. If the hydrogen is moving from here, you will get this product. If the hydrogen is moving from there, your product will be like this: CH3, CH2, CH, double bond CH2. Are they isomers? Yes, sir. What type of isomers they are? They are structural isomers. They are structural isomers because this is but2ene. This is being but2ene and that is being but1ene. They are position isomers because the position of double bond is being different. Now, my dear friends, once they did experiment and what they have got, that it was formed 80% and that was formed 20%. Now they have started doing their studies how to justify. Then what they did, kids, they have seen in number of examples. This is the alkene. Why I'm taking it like this? This is sp2 hybridized carbon. This is sp2. Whatever is left, they said they are alkyl group. This side one alkyl is left, Can you see? This side one alkyl is left, that is that side also one alkyl is left, both the side alkyl is there. Can you see, kids? Can you see, kids, what I'm saying, what I'm telling you? Both the side alkyls, two alkyls are there, so they said this is di-substituted. This side alkyl, that side alkyl, so it is being di-substituted alkene. Di-substituted alkene. Now, if you're really able to understand, tell me how much substituted alkene it is. If you really got it, if you are able to understand, do let me know what is the substituted alkene it is. Then your answer should be it is mono-substituted, because on this side, left hand side, it is being substituted. This is being sp2 hybridized carbon. So it is attached with alkyl group on the left hand side, but nothing is there on the right hand side. So it is being mono-substituted. I can see in the chat, very good, Nishant and Hurdaya and everyone, very good. Now this is mono-substituted, kids. If you got it, this is mono-substituted. Now which one is more substituted? Definitely answer will be out of these two, this is more substituted, this one is more substituted. Out of these two, this is more substituted. More substituted alkene is known as jet-sep product. More substituted is known as jet-sep, and it is also pronounced as set-jef. Some people call it set-jef, some people call it jet-sep, and set-jef product will be major. And the less substituted is known as Hoffman. Hoffman. My dear students, I hope this point is very much clear to all of you, and this slide is also very much clear to all of you. Kids, do let me know in the chat section whatever is written in this slide. Whatever is written on this slide, is everything is clear, kids? Kids, Dishant, jet-sep and set-jef are same name. Let me write down. jet-sep, just like Mohandas Karamchand Gandhi, Bapuji, they are same names. These two are also same names. You got it? jet-sep or set-jef, they are same names. Same person's name. They are same. Now, my dear students, first of all, I would like to see green hearts in the chat section. Very good, Movin. Very good. You are not able to understand, then watch the lecture from the starting. Kids, rest of others are able to understand. Movina is writing, I am not understanding your point. Rest of other students, do let me know. That's why I'm asking whether you are able to understand or not. I would like to ask with each and everyone that only one kid is not able to understand, or rest of the others are also not able to understand. Kids, those who are able to understand, do show me green hearts, green leaves, green signal. Now kids, these two products are formed in different percentage. Very good, very good. Now one is set-jef, one is Hoffman. If I say that this one is X and that one is Y, if I say this one is X and if I call it this one to be Y, is there any relationship in between X and Y? Yes, they are structural isomers, and one is formed in major amount, another one is formed in less amount. So this funda is known as that E2 mechanism follows regioselective. Regioselectivity, E2 reaction is regioselective. What does it mean? If this word is coming, kids, E2 reaction is regioselective. What does it mean, kids? What does it mean? If they are asking E2 reaction is regioselective, what will you say, kids? What is the meaning of this? E2 is regioselective. What is the meaning of this? Regioselective. This is very, very important thing, kids. You can't skip it. They will ask and you have to answer it. So regioselective means when one of the structural isomer, when one of the structural isomer is formed in major amount, is formed in major amount. This is the meaning of regioselective. Regio deals with structural isomerism. Remember that regio deals with the structural isomerism. Now one more word will come. Just listen, one more word will come. E2 is stereoselective also. What is the meaning of this? Stereoselective also. What does it mean, kids? Stereoselective also. Now regioselective, after regioselective the word has come stereoselective also. Now remember that when one of the stereoisomer is formed in major amount, is formed in major amount. Now what is the meaning of this, kids? The meaning of this is that if I deal with butanene can't show geometrical isomerism, but butene can exist in two forms. Butene, kids, just see, butene can exist in two forms. What are these two forms? Just see that trans-butene and cis-butene. Out of these two butene, trans will be major. Trans will be major. Why trans is being major? What's the reason for trans being major? The reason is that bulky groups are on opposite side. If I say this is upper side, this is lower side, but there both of the two bulky groups are on the same side. So this is less stable, this is more stable, more stable, more stable, this is more stable, that is less stable. Bulky groups are on same side. Now my dear students, two bulky groups are on same side, then van der Waals repulsion will be maximum. What is van der Waals repulsion? Atom repulsion. There is no hydrogen bonding, so there is nothing like love. They are going to attract. So their van der Waals repulsion will be more. And one more thing, the bonded electron will repel. Electron, they are having negative charge. There will be repulsion in between electrons. That is torsional strain. If you have studied conformational isomerism, you must know what is torsional strain. So it is having more van der Waals strain and more torsional strain. Van der Waals strain is maximum and torsional strain is maximum. Now my dear students, I have told you each and everything. Now if they are going to ask question that they have given you, kids, they have given you question like this: CH3, CH2, CHCl, CH3, KOH, alcoholic, heat. Now how many alkenes will get formed? If the question is how many alkenes will be obtained, what should be your answer? How many alkenes? So what's your answer? Do let me know what's your answer, kids, in the chat section. How many alkenes? I'm waiting for your answer. If your answer is, do let me know what's your answer. Om Prakash Bala, welcome, welcome, welcome. How many alkenes? How many alkenes? That's my question. How many alkenes? That's my question, kids. So some of you will say two alkenes, but the answer is three. Answer is three. Why, kids? Because maximum portion will be of trans butene, then cis butene, and at last it will be cis butene, and least will be butene, because butene cannot show GI. Now my dear students, these two are having relation of GI. They are diastereomers also, I can say. They are diastereomers, or we can say they are GI of each other. Now my dear students, this is transbutene, cis-butene and butene. These are the three products. I hope that everyone is able to understand. This is the percentage of formation and 3 is the correct answer. If you really got it, I want to see green signal in the chat section. My dear students, do let me know everyone got it. Now, two things I taught you, that E2 reaction follows regioselectivity, it follows stereoselectivity. Now, one more word, that is for rank deciding. I am going to tell you that E2 reaction is following anti-periplanar mechanism. This is dangerous word. E2 reaction follows anti-periplanar mechanism. What does it mean? What does it mean? It's E2 reaction, E2 mechanism follows anti-periplanar mechanism. Anti-periplanar mechanism. Now, this is only for rank deciding kids. Everyone should not prepare for it. If your motive is to achieve more than 650 marks, if you want to get more than 650 marks, then only go for this. If your choice is to get more than 650 marks, then only go for it. Otherwise, you can leave it, you can skip it. Now, what is the meaning of this? Let me tell you. There is carbon, there is carbon. Now, the valencies, I would like to say the halogen should be like this, coming towards observer side. The halogen, if it is coming towards observer side, then hydrogen must going away from observer. Now, rest of the valencies, let me keep it like this only, no problem. Wherever you want to attach, you can attach. This halogen and this hydrogen, they should be parallel and they should be opposite. Parallel, one thing is parallel, and if this halogen is coming toward this side, downside, hydrogen is going upside. They hydrogen and halogen must be anti as well as planar, both. Why it is required? Why it is required? So let me tell you kids, if this is bonding molecular orbital BMO, what is the meaning of BMO kids? BMO means bonding molecular orbital. If this is bonding molecular orbital, then its anti-bonding will be on the opposite side. This will be ABMO, anti-bonding molecular orbital, and that is empty without electron. Now, its bonding molecular orbital is over here. Its BMO is over here with electrons. Now, as soon as alcoholic KOH is going to come, what is going to happen? Let's see. K plus will try to come from here and OH negative will come and try over here. They will start forming a bond formation. This K will say to X, I need you, I need you, I need you right now. Let's go with me by taking your electrons as well as electrons of carbon. And this OH negative will say, come without electrons, come without electrons. So this condition is transition state formation. Transition state formation, that means bond cleavage till now has not taken place, but they have started in doing interaction. So if I say this is a reactant, now how the transition state will look like? Let me show you the transition state, the TS. Just try to see how the TS will look like, then only you can find out what I am telling you, kids. That this halogen started breaking its bond with this carbon and now started forming bond with K plus. Neither the bond has broken completely nor the bond has formed completely. This side breaking, this side making. Are you getting my point? From here, breaking of bond. Here, this place, breaking of bond. Just see, breaking of bond is taking place. At this place, breaking of bond is taking place. Let me make it small. How is small? Yeah, or more small. Is it visible? Breaking of bond, and here making of bond. Neither breaking nor making has taken place, but they are making of bond is taking place. Breaking of bond and here making of bond. Kids, are you getting my point? This is the transition state. I hope that it's clearly visible. Breaking of, neither the bond has broken completely nor the bond has formed completing. Breaking of bond and making of bond. Now here its ABMO is growing up. Its ABMO is growing up because bond is breaking. So the size of ABMO is increasing. Remember that how strong BMO is, that small ABMO is. If BMO is not stable, ABMO will be bigger. If there is no bond, both the lobes will be of same size because it's a pure p orbital, right? Now see kids, here also that hydrogen is breaking a bond and making of bond is taking place with OH negative. Now that means at the same time, this carbon is developing negative charge and this carbon is developing positive charge, and these two lobes, they will start forming a pi bond. Kids, are you getting my point? And that's why just of this pi bond formation, I have told you, they should be present on the same side. How they can form this bond, partial bond formation is taking place. How this bond formation can take place? For that, these two must be lying opposite. If these two are lying opposite, then they will be on same side. For them to be on same side, it's very necessary that hydrogen and halogen, they must be on opposite side. If they are anti-periplanar, if they are anti to each other, then only they are going to be planar. Then only they are going to form a pi bond. I hope it's clear. It's clear. Now, what type of question will come in your exam? Let me tell you what, once the mechanism is clear, at least show me green hearts, kids, that yes, we got it, kids. At least you can show green hearts if you are able to understand anything, kids. I'm telling you each and everything in detail, kids. This is the transition state, highly unstable. Transition state, highly unstable. Now, what is happening in transition state? Two sigma bonds are breaking and one pi bond is getting formed. After some time, they will form a bond. Now, see kids, what type of question will come and how to give the answer of that question. So, see, this was the question. This was the question. E2 follows anti-periplanar mechanism. Now, see, this shows that bond is coming towards observer side. What is the meaning of this? Towards observer side. And remember that in flying wedge dash formula, let me tell you, first of all, flying wedge dash formula means what? Whenever you talk about flying wedge dash, whenever we talk about flying wedge and dash formula, we should remember one point, that carbon is having 4 valencies. Carbon valency is 4. If one valency is coming towards observer side, if one is coming towards observer side, this is written as wedge. If I say with carbon, this chlorine is attached, that is coming towards observer side, right? It is coming towards observer side, that means it is coming towards your side. And if I say this is written like this is known as dash, so I will say this hydrogen is going away from observer. This is meaning away from observer. This means away from observer. Now rest of the 2 valencies will lie in the plane of paper. These 2 will lie in the plane of paper. Pop means plane of paper. 2 valencies will always remain in the plane of paper, one coming towards observer side and another one going away from observer. Now see kids, in the question you can see that bromine is wedge. Wedge means it is coming towards observer side. This is alpha carbon, this is beta carbon, this is beta carbon. Now see kids, on this beta carbon, this is also wedge, that means towards observer, and 2 valencies are in the plane of paper. Pop, plane of paper, plane of paper. Now who is missing? Only hydrogen is missing. That is clearly indicating that hydrogen is going away from observer. As I have told you, in the flying wedge dash, one is coming towards observer, one is going away, and 2 in the plane of paper. Now see, this is coming towards your side, that is going away, your side away. They are anti to each other. Bromine and hydrogen are anti to each other. I hope you got it. Now if I say on this beta carbon, this is going away, if this is going away and these 2 are in the plane of paper, that means hydrogen is coming towards observer side. Hydrogen is coming towards observer side. If one is going away, so another one must be towards observer side. So this bromine and this hydrogen, they are syn. Syn means they are on same side. But E2 reaction follows anti-periplanar mechanism. So who will eliminate? Right hand side hydrogen will eliminate or left hand side hydrogen will eliminate? Just to let me know kids, this hydrogen blue one will eliminate or this hydrogen green will eliminate? Kids, do let me know which hydrogen is going to eliminate, or should I say red one? This is a red one. Which one will eliminate out? Red one will eliminate out and your product will be like this. So this was the toughest question. If they're asking this question, then you should be prepared of this question, kids. I hope it is clear to all of you. How many you are able to understand? How many of you are able to understand? Do let me know, kids. If this answer is clear, then definitely. If this one is clear, then another one for sure you can do. This is one more question, and do let me know what's your answer. If you are able to understand that one, you can do this one also, kids. Let's see who is able to do it. Do let me know in the chat section how many of you are able to do it, kids. Yes, kids. What's your answer? Fast. Everyone. Everyone, I want to see your answer. Everyone, just to let me know what's your answer. Fast, fast, kids. Just half an hour more, kids. At 11, I will finish it off. Whatever we are going to deal with, whatever till that time we are going to deal with. Okay, half an hour more. Means at 11, I will complete whatever. Rest of the part I will take in another session. But fast, kids, fast. So you were not able to display so fast the chat. See, somebody is making chat to run very fast. Very good. Wow, that's really awesome. Great, great. Wow, the chat is running very fast. Kids, you try to give the answer. Let me see what's the answer. B. Soumya is going for B. Movina is going for A. Let's see what other kids are going to say. D. Somebody is going for A, somebody is going for B, somebody is going for D. Now, kids, what should be the answer? Now, see, kids, try to understand that this bromine is coming towards your side, and this bromine is away, so its hydrogen is towards your side. Means they are on same side. Away, then this is towards, then the hydrogens are on the same side. Everywhere it is like this, which will not show E2 reaction. So this is towards, this is towards, this is away, then the hydrogen is towards. And if you see, this is towards, then the hydrogen is away. In this one, no hydrogen is anti. I can say no hydrogen is anti. No anti-hydrogen is there. Do let me know, am I right or wrong? No anti-hydrogen is over here. In others, you can say if this is coming towards your side, its hydrogen is away. So these are anti to each other, will take place. Reaction will take place because they are anti to each other. In this, if I say this bromine is away and this bromine, this is okay. So I can take this is towards your side, this is towards. So this hydrogen will be away. So this bromine towards, so anti-hydrogen is there. This also E2 will take place. In this one, if this is towards your side, this is towards your side, the hydrogen will be away. So these two are anti to each other. In this also, E2 reaction can take place. But in this, there is no anti-hydrogen, so reaction won't be able to take place. Am I right, kids? How many of you are able to understand? Do let me know, kids. Now, kids, in Baba's class also, people, and you know from which place these people are coming. You know from which place these people are coming, and this is your love towards your Baba side, that you made people to visit HSP's class. Now in HSP's class also, these spammers started coming, and you know from which coaching they are coming. You know from which coaching these people are. Okay, so that's your love, and these spammers are there. That indicates that wow, that your HSP sir is doing a great job, right? That's why they are worried. Yeah, Baba is a grown-up child. Baba is the father of these kids. Now, kids, should I give you one question, normal question? Just see. If I give you one normal question, just see to it that if they are giving question like this, simple question, just see. Methyl bromine KOH alcoholic heat, KOH alcoholic and heat. Which one will be major? Let me write down two options. One is this one, this say X. One is this one, this say Y. Do let me know. Out of these two, which one will be major? Which one will be major? Fast, kids, fast. Out of X and Y, which one is going to be major, kids? Fast, kids. Do let me know. Fast, students. Yeah, you will get PDF for all the three sessions. I will ask the team to share it for GOC as well as isomerism along with this hydrocarbon PDF. First, I want to see the answer, but you are taking too much time, kids. Which one will be the major? X1 or Y1? You are not giving the answer, kids. Fast, speedily, I want to see the answer, kids. Hey, I want to see the answer. You are taking too much time, kids. Now see, kids, this is your alpha, this one is your beta, this one is your beta. Now see, which one is more substituted? If you see this alkene, this side alkyl, that side alkyl, this is being di-substituted. It is being di-substituted. Got it? Now, if you see this one, this side, and this side, this is being tri-substituted. Definitely, which one is more substituted? This one is being more substituted, and the one which is being more substituted is your ZJF or JETSEP product, and ZJF or JETSEP is being major. So, Y is your major. I hope that everyone got it. I hope that everyone got it. Everyone, is it clear? Now, let me give you one more question. Let's see whether you will be able to give the answer to that question or not, kids, right? So the question is that if they are asking that I'm having neopentyl chloride, we are provided with neopentyl chloride. So kids, if you don't know the structure of neopentyl chloride, you should know. This is your neopentyl chloride, and they are reacting with KOH, alcoholic and then heat, alcoholic and then heat. What should be your answer? Its name is neopentyl chloride. It is being neopentyl chloride. Kids, do let me know what's your answer. Do let me know in the chat section what's your answer, kids. Then you will find out that no reaction will take place. No reaction. Kids, do let me know why no reaction. If you see clearly that this is being alpha carbon and this is being beta carbon, there is no beta hydrogen. There is no beta hydrogen. Can you see, kids? There is no beta hydrogen, so reaction won't be able to take place. Now, my dear students, let me tell you clearly that during E2 reaction, most of the time ZJF is the major product, but not always. Let's see. Let me write down this statement also. During E2 reaction, in E2 reaction, E2 elimination, mostly ZF is major. But kids, but not always, but not always. Now for this, let me tell you, there are some following cases, there are some special cases, there are some special cases, there are some special cases in which ZF or Hoffman can be measured. ZF or Hoffman can be measured depending on the situation. Can be measured depending on the situation. Depending on situation. Now kids, how many of you want to know that what is that situation? That this is very important point I would like to say. Maximum question will come from here only. That was the simple thing, but maximum question will be asked from here only. What are these special cases? How many of you ready, kids? Everyone just to let me know how many of you ready. I cannot see your chat, kids, where you have gone. Somebody is spamming, only spammers chat I can see. I can't see your chat, kids. You are many and the spammer is one or two, only one or two. You start flowing hearts, then spammer will not be there. Spammer's chart will not be visible, kids. You start flowing hearts, green hearts, then you see spammer's chat will not be visible. Do once, let's see. At least try it out. Everyone just flow the green hearts, thumbs up, whatever the emojis you are having. So see, he won't be able. These are paid spammers. Their chats won't be visible, kids. I'm telling you. Just try it out. Just try it out, kids. To every action, there should be equal and opposite reaction. You are many. He is one or two only. Let's see. Let's see whose chats are visible. Let's see, kids. Let's see whose chats is visible, kids. See. Now see, kids, whose chat is visible. Always in your society also, if one bad person is there, if somebody is disturbing, always come in unity, then that person will run away. Then that person will run away, will not be visible. See, the visibility has gone down, this person's. This person is not visible. Now see, kids, thank you. Thank you. Unity means a lot, kids. Unity means a lot. We can see unity matters a lot. Wow, kids. Wow. Now see. What happened? Hey, spammer. What happened to you? Where you have gone? Where you have been lost? See, kids. The power. Okay, let's see. Now let's study. Now see, kids. Special case number 1. Special case number 1. First special case. That is when X is fluorine, when X is fluorine. In case of fluorine, just see kids what is going to happen and what's new. If they have given question like this, CH3, CH2, CH, fluorine, CH3, NaNH2 heat. Now my dear students, the things will get changed. Things will get changed. Why and how? See kids. This is dye substituted. So dye substituted, and that is mono substituted. So the more substituted one is ZJ product. So this is ZJ, right? Or ZZ we can say. That is being Hoffman. Now see kids. ZJ is more stable, but it will be 20% only, and the less stable one is formed 80%. This is really special, something special, that more stable is formed in less amount, more stable but formed in less amount, and the less stable is formed in more amount. This is being less stable but formed in more amount. This is very, very important thing. Now, how many of you want to know the mechanism? When the fluorine is the leaving group, this happens. This happens. Now, how many of you want to know the mechanism of this question? Let's see the mechanism of this question, how this reaction will move. Get C. CH3, CH, H, CH, fluorine, CH2, H. Why I have taken out these hydrogens? Alpha, beta, beta. Now kids, as soon as alcoholic KOH is coming, OH negative will start forming a bond with this. OH negative will start forming bond with this, but K plus won't be able to form a bond with this. Why? Fluorine is saying my bond is being very, very strong bond. What fluorine is saying? My bond is very, very strong bond. What does it mean, very, very strong bond, kids? This means, kids, that carbon is 2p. Definitely carbon is 2p. And fluorine is also 2p. So 2p bond is very, very strong bond. Are you getting my point? This bond is very, very strong bond. Carbon 2p, fluorine 2p. In between 2p and 2p, very, very strong bond. So K plus won't be able to form a bond with this. Then what is going to happen? They will start forming bond, and see how the transition state will look like. How will you see the transition state, kids? CH3, CH, H, CH fluorine, CH2, H, and now OH negative or NH2 negative, NaNH2 we took. So let me write down NH2 negative. So NH2 negative will start forming bond with this. NH2 negative will start forming bond with this. So it will go while leaving electrons. So it will get negative charge and it will also get negative charge because H plus will go with NH2 negative. Are you getting my point? This is the transition state, kids. Can you see the transition state? This is the transition state. Is it visible to all of you, the transition state, kids? Kids, have you seen one thing? Still one person is over there. So see how jealous these people are. But I have no grudges with this person. They are paid spammers. So you do whatever you want to do. I'm cool person. I will keep on teaching. Let me have a sip of water. See, kids, number of obstacles will come in your path. But where there is a will, there is a way, is an old saying, but still true. All the obstacles will disappear and the means to its achievement will appear in front of you, kids. See, kids, such type of people will definitely run away. My HSPN army is very strong. They can throw number of comments for Baba HSP. Thank you, thank you, thank you, thank you. See, now what the spammer will do? Spammer won't be able to do anything. Hey, spammer, what happened to you? Where the spammer has been lost now. Thank you, Hope. Thank you, everyone. Ritesh, thank you, thank you, thank you. Now, see, kids. This transition state is indicating that earlier what was happening? This bond was breaking, simultaneous pi bond formation was taking place, but here pi bond formation is not able to take place because this bond is very, very strong bond. It's all because of this bond. This bond is being very, very strong bond, and that's why nothing is happening, kids. This bond is not breaking because it is very, very strong bond. So they have developed partial negative charge. I'm not saying negative charge, because if negative charge would have been developed, we have to say that carbon ion has been formed, and carbon ion is an example of intermediate, but we are dealing with E2 reaction where intermediate formation does not take place. So no intermediate formation. Now, my dear students, in the transition state, partial negative charge, partial carbon ion is formed. So remember that in transition state, partial carbon ion formation takes place. Carbon ion formation takes place. That means this is the key point. So do remember, rate of this reaction is directly proportional to what? Rate of reaction is directly proportional to stability of partially charged carbon ion partially charged carbon ion. This is the key point. Very, very important. Very, very important. Very, very important. Very, very important. This is very, very important. $1,000,000 thing, kids. $1,000,000. I would like to say it's $1,000,000. Stars, whatever the stars I can provide, I'm going to provide stars to it. Now kids, this is a $1,000,000 thing. Now, so this is 1 degree carbon ion and that is 2 degree, and in carbon ion who is being more stable? Definitely 1 degree carbon ion is more stable. So this is more stable. Don't see the product stability. Whenever the fluorine is given over there, never see product stability. Always see partially charged carbon ion stability, kids. What I'm saying, whenever fluorine is given over there, never see product stability. Always see carbon ion stability. Let me write down this statement because this is really very important. Then only I will write down the product. Whenever fluorine is, whenever halogen is fluorine, never see product stability. Then what we are supposed to see? Just focus on what? Just focus on partially charged carbon ion stability. Partially charged carbon ion stability. That matters a lot. This matters a lot, kids. Partially charged carbon ion stability. So always go for this. Whose carbon ion, that is partially charged carbon ion, is being more stable, that product will be more stable. So now you must have seen that 1 degree carbon ion is more stable. That's why its product will be major. But number of times what happens, kids, only one example is given in many books, and students are going to study with that book and they fall in love with that book, and whenever they see fluorine as the leaving group, they mark Hoffman as the major product. But kids, you will get failed. See, if they are going to give you a question like this, whatever I am writing, you will get marks from there only, kids. So just focus. If they have given question like this, C6H5 CH2 CH fluorine CH3 plus NaNH2 heat. This is known as soda amide. Number of times I said, remember the names also. Soda amide. Now see, whenever you see fluorine, what you are supposed to do? You will say Hoffman product is major, but don't ever do such type of mistake. Why, kids? This is your 1 degree carbon ion alpha, beta. Why I am talking about these two only? Because they are beta and we are studying beta elimination. This carbon ion formed will be 1 degree and this will be 2 degree. So whenever resonance takes place, degree does not work. Remember that. In case of resonance, degree doesn't work. This carbon ion will be stabilized by resonance. So never see degree in case of resonance. This carbon ion is more stable. More stable. So this time, this product will be formed in major amount. This one is major and that one is minor, kids. Now see kids, this one is minor. So kids, see to it clearly. This is still your subject, because if you see this alkene, that side also alkyl, this side also, this is being di-substituted. So it is being ZJF, or you can say at the same time ZJF or JetSep. Both mean same, ZJF or JetSep. And this is, you can see this is alkene only one side. So this is being mono substituted kids. Mono substituted is your Hoffman. So see, I have given you two examples where fluorine is the leaving group. In one case you saw that Hoffman was major. In one case, you have seen that Sedgwick is major. So never go with the product stability. I'm telling you again and again, whenever fluorine is the leaving group, focus on the partially charged carbanion stability. The one whose partially charged carbanion is being more stable, that will be responsible for major product formation. I hope that everyone is able to understand this point. Is it clear to each and everyone, kids? My this point is exactly clear. Everyone got it. So whenever fluorine is leaving group, never say that Hoffman will be major. Never say that Sedgwick will be major. Just go with the stability of partially charged carbanion. Then just check it out who is going to be major. Everyone got it, kids? Just to let me know. I want to see green signal from everyone's side if this point is clear. Now, I will tell you about two more reactions, these two special cases, and whatever the time these two special cases are getting completed, at that time I will stop this lecture so that you can take your sound sleep. Okay, my dear students? So nothing to worry about it. So, okay, don't worry kids, right? So just go with the lecture with full on Josh. I want to tell you each and everything in detail. I don't want to skip even a single thing, right? Now I'm going to deal with this one. Rest of the hydrocarbon I will complete in lecture number 2, hydrocarbon part 2. But I'm not going, okay? Now see, special case number 2. Let's see the special case number 2, my dear students. Second special case, and this is known as he. What do you mean by he? Hoffman exhaustive elimination. Special case number 2. That is Hoffman exhaustive elimination. He, it's not he man, just he. Say everyone he. He means Hoffman. Now see, if you are studying this haloalkanes, no need to go with this in class 12. Once it is completed over here in hydrocarbons, that will be beneficial over there in haloalkanes, haloarenes. Everything is coming twice or thrice. Hoffman's exhaustive elimination. So how will you recall this reaction? So remember that whenever you see any quaternary ammonium salt, whenever you see any quaternary ammonium salt like nitrogen attached with methyl, methyl means 4 valency, it must be having 4 valency. So nitrogen is having 4 valency. Sir, draw once again the structure, not getting it. Okay, kid. See, Baba is talking to himself only. If I say nitrogen generally do have 3 valency, but if I put 4 valency, then nitrogen will develop positive charge. One point is clear. Then I will say to satisfy this positive charge, there must be some negative thing just to satisfy this charge. So if I write X negative, now it is ammonium salt. Now I think it's clear. Now, if they have provided it with compound like this, just see, I will definitely say this is your quaternary ammonium salt. I hope now everyone got it. Now, why I'm interested in this one? Let's see. The quaternary ammonium salt should have quaternary ammonium salt must have at least one beta hydrogen. Must have at least what? Everyone say must have at least what? Must have at least one beta hydrogen. Now let's see what is beta hydrogen. To nitrogen directly attached is alpha, directly attached alpha, directly attached alpha, directly attached alpha, beta carbon, and hydrogen is beta, beta carbon, beta hydrogen. Don't see all these because they are not having beta carbon, so no beta hydrogen. So this is beta hydrogen and this is beta hydrogen. Remember that the same mechanism as fluorine case. Yes, exactly the same mechanism as we did it right now with the case of fluorine. With the case of fluorine, I will give break. I will give break. Okay, just I will after 10 minutes I will give one break. Okay, kids. Just after 10 minutes I will give one break. Okay, kids. Small break. I will give small break. Now, see, the strong base will come over here. Strong base, and generally they will give you Ag2O, 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 and temperature, right? So this base will come over here. Base will come over here and it will take away this proton. So it will develop partial negative charge. Base will come over here and it will take proton. It will also develop negative charge. So in this also, in the transition state, partially charged carbon ion will get formed, and its a mechanism is same like the fluorine case. So rate of reaction will be proportional to, directly proportional to partially charged carbon ion in TS. So the mechanism is same like special case number 1. The mechanism is same like special case number 1. So this will go negative and this nitrogen will take electron positive. Now let me show the complete reaction on next page. Otherwise you won't be able to understand over here. Let me draw that compound once again. Nitrogen, methyl, 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 carbon, CH2H, CH, CH3, Now see, this will go along with base. It will develop negative, and nitrogen will take, later on it will take electrons, so it will develop positive charge. So nitrogen will get eliminated out. It will become 3-degree amine pyramidal shape, and this will be, one compound will be like CH3, CH2, CH, double bond, CH2. This is Hoffman. And in this case, for this case, I would like to say it is major. And one more alkene will be formed if that is going from there. This is Sedgwick, but here this is minor kids. But if it would have been benzene, then Sedgwick will become major and Hoffman will become minor. My dear students, are you able to understand this much? Everyone. Now let's take one small break and let's meet at 11:15 p.m. right? Small break, or should I teach you? Later on we can take a break. Do let me know. Decide, kids. Do let me know. Let me see in the chat which side majority of people are. What is my students' demand? Whatever my students need, I will do that. Small break. Do let me know, kids. Whatever you say, I will do that. Because you are very, very special for your Baba HSP. Whatever you say. When we sleep at 12, it will be up to 12 because people are liking this class. So I will move up to 12. Break. Okay. So, okay. Last special case duration. Okay, let me deal with last, because last special case will require just 5 minutes. Last special case will require 5 minutes only. So let's deal with that. Okay. Then after that, I will give break. So just for 5 minutes more. After 5 minutes, I will give small break, right? Third special case. Third special case, kids. That whenever bases like this, this is very, very famous base. It can be written like this, or it can be written like this also sometimes, or sometimes it is written like TBU. Potassium tertiary butoxide. Remember that. Potassium tertiary butoxide. Whenever such type of base is given, why this base I am talking about? It's very good base, very strong base. Why it is being very, very strong base? Because 3 plus I, they are electron donating group. They are donating electron to this oxygen and it is becoming highly electron dense. But it is, yes, along with it is being strong base, it is too much sterically hindered. It is too much kids, what? Too much sterically hindered. Now, one sterically hindered can't reach to another sterically hindered thing. If I say there is very green grass in the forest, but it is just in between one place which is being sterically hindered by very big trees. So rabbit can reach over there, but elephant won't be able to reach at that place. So just see, if I write this reactant, now you can see beta hydrogens. This carbon attached with alpha is, this is alpha, this is beta, this is beta. Now you can see two types of hydrogens. One is this, uh, one is this yellow one is this one, and another one is this red or purple one, which can be easily snatched by this strong base. Which hydrogen can be easily snatched? This is easily accessible. Am I right, kids? Can be snatched easily. This one can be snatched easily. Am I right, kids? But if you think about this hydrogen, this is too much sterically hindered. If I talk about this hydrogen, too much sterically hindered, tough to be taken out. So definitely the one which can be easily snatched will be responsible for major product. So its major product will be CH3, CH3, CH double bond CH2. So always we can say less substituted product will always be major. Hoffman will always be major in such case. Hoffman will always be major, and Sedgwick will always be minor in this case. Kids, I hope this special case is very much clear to all of you kids. Sedgwick will be minor. This was the special case number 3. All 3 special cases I have told you. Dehydrohalogenation E2 is completed, but in E1 will require shifting, migration. Then I will, once I am going to tell you about E1 dehydrohalogenation, then dehydration will become very easily. So my focus is just to complete preparation of alkene. Once alkene preparation is completed, then in next lecture I can deal with chemical properties of alkene and then alkyne. Okay, and for that we will require only 1 hour. Up to 12 I will complete it by teaching you, by telling you each and everything, right? So let's take one break. Let's meet at 11:20, right? 11:20. Okay, kids? But kids, come with ATPs, come with a lot of ATPs. Will you do that? Then only we will take one break. Come with 1 mole ATPs. Come with 1 mole ATPs. Right? Will you come? That is high Josh. That is come with high Josh. Kids, then only I will give you break, otherwise I will not. If you can do this, then only take a break. Otherwise, not. Kids, do let me know. Will you do that? Will you do that? Make a promise that you will come with high Josh. Everyone. Very good, Darshana. Thank you. That's really awesome. Rising star, fantastic. It's, see, in this, the smallest hydrocarbon containing secondary carbon. This is by chance. It's the slip of marker. It's hydrogen only, right? It's hydrogen only. Here it's hydrogen. Hydrogen only, right? So this is the answer. So sometimes it happens that you are thinking of something else and you have written something else. So 1 degree, 2 degree, 1 degree. Otherwise, if it is CS3, it would have been 3 degree, right? Kids, are you back? Everyone? Everyone, just to let me know. This one, propane, 1 degree, 2 degree, 1 degree. It was written CS3 by chance. Okay, slip of marker. Everyone got it, kids? Everyone who has asked this question, you got it? It's being propane, the smallest hydrocarbon containing secondary carbon. So it's being propane. Is it clear? Oh, my dear friends, just to let me know. Am I audible and visible to all of you? Kids, do let me know. Everyone can hear me, can see me. If I'm perfectly audible and visible to all of you, do let me know, kids, my dear friends. Just to let me know, everyone. Hey. And propane, yes. Who has asked this question? This question was asked by whom? Somebody asked this question. Is that kid is there or not? That student is present or not right now? Just to let me know who asked this question. That is smallest hydrocarbon containing secondary carbon. So by chance there was CS3. So just everyone, are you there? Okay, so let's go with next. Preparation of alkene. We were dealing with preparation of alkene kits. So special case and everything I've told you. Now dehydrohalogenation. Let's deal with dehydrohalogenations. All the cases we have done. Now even mechanism. Are you ready for the even mechanism, kids? Is everyone ready? Even. Before we move with even, kids, remember that even mechanism will take place with weak bases. Weak base. Weak base is required. So what are the examples of weak base? That means ROH plus heat. We will get ROH plus heat. So they will follow multi-step reaction. Now what I say, rearrangement is possible. So we have to focus on rearrangement, right? Everyone in this reaction, because this is multi-step reaction, and multi-step reaction, if I say, then rearrangement possibility is there. In multi-step reaction, rearrangement may take place. So we have to understand when the rearrangement will take place and when it will not take place, right, kids? Types of rearrangement, we have to see types of rearrangements. So kids, are you there? If you are there and your Josh is high, as we have promised that we will come with high Josh, so I want to see that Josh in the chat section in the form of fire. Everyone, show me some fire. Show me some fire in the chat section. I want to see that fire in the chat section. Now, types of rearrangements. Let's deal with types of rearrangements. Rearrangement types. rearrangement types. Now see kids, first I would like to say 1,2 hydrate shift. 1,2 hydrate shift. What is the meaning of 1,2 hydrate shift? Let's understand. Everyone, let's understand. What is the meaning of 1,2 hydrate shift and why it is 1,2 only? Why not it's 1,3? Why not it's 1,4? Let's see. Suppose if somebody has given you a carbocation like this, CH3, CH, CH3, CH plus CH3. Now this carbocation, if you see this carbocation, it's not having resonance. It's not being resonance stabilized. It is stabilized by hyperconjugation. And if I talk about stabilized by hyperconjugation, so for hyperconjugation, we are interested in alpha hydrogen 1 and 3. 1 plus 3, it is having 4 alpha hydrogens. And if I talk about stabilized by inductive effect, it is attached with 2 more carbons. So it is 2 degree. I hope it is clear, 2 degree. Now, if hydrogen is shifting from here, if hydrogen gets shifted from here to here, by only this hydrogen, if that hydrogen is getting shifted, then you will get even lesser stable carbocation. But if you shift this hydrogen, the carbocation formed will be like this. This carbocation, you will get, my dear students, you will get this carbocation. Now let me know kids, if I say that one was X carbocation and this one if I say is being Y carbocation, do you think that Y carbocation is being more stable than X carbocation? Do let me know kids. Do let me know that Y carbocation is being more stable than X carbocation or less stable. Just to let me know kids, which carbocation is more stable, X or Y? So sure, for sure, this carbocation is being more stable. Why? It is also stabilized by hyperconjugation, but right now 3, 3 and 2. 3 plus 3 plus 2, 8 alpha hydrogen atoms are there and it is stabilized by inductive effect. It is being 3 degrees. So better in both the two cases, it is better than that. So more stable, more formed. Remember that. We will never say more stable is the only carbocation which is going to form. More stable, more formed, more responsible for major product formation. Everyone, very good. I can see everyone is writing. So remember that more stable, more formed, more stable, more formed, more responsible for major product formation, more responsible for major product formation, for major product formation. I hope you got it. So this carbocation is more responsible. So this is 1,2 hydride shift. If you got it, I want to see green hearts. Now, 1,2 methyl shift. Let's focus on 1,2 methyl shift. Just see 1,2 methyl shift. What is the meaning of 1,2 methyl shift? Everyone just see 1,2 methyl shift. Methyl is CH3 negative. Along with electron, it will shift. See how and why. If I say this is an organic compound, CH3, 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 CH positive and CH3. Now see, if this methyl is going with electron to the next carbon, why only 1, 2? This is 1, then this is 2. From where it is migrating, we will mark that to be 1. And where it is going, we will mark it to be 2. So 1, 2, it is known as 1, 2 because they will form a bridge. Then only 1 to 2, not 3 nor 4, neither 3 nor 4. 1 to hydride, no, 1 to methyl shift. So we will get CH3, C positive, CH3, CH, CH3, and that methyl has been shifted over here. Just see, this carbocation is having 3 alpha hydrogen and only 3. So it's stabilized by hyperconjugation, that it is having 3 alpha hydrogen atoms, and is stabilized by inductive effect, that it is being 2 degree. But that one's better than that. See, 3, 3 and 1. Stabilized by hyperconjugation, it is having 3 plus 3 plus 1, that is 7 alpha hydrogen atoms, better than that, and it is stabilized by inductive effect 3 degree. So more stable, more formed, more responsible for major product formation. More stable. I hope this much is clear to each and everyone. If two things are clear, then the toughest one is ring expansion. When to do? Very good, very good. Ring star, rising star, sorry, Kumudha. You people are really awesome. Jaslyn, wow, kids. Now, after these two, let's deal with the third one, that is ring expansion. It holds a hell lot of weightage. Let's try to understand ring expansion, kids. Ring expansion. Now, first thing, remember that whenever the charge is on the ring, no ring expansion will take place. Whenever the charge is on the ring, whenever charge is on the ring, ring expansion can't take place. No ring expansion. Why no ring expansion? Because charge is on the ring. Charge is on the ring. So no ring expansion. Second thing, whenever you are provided with 3-membered ring and it is positive charge, it is stabilized by dancing resonance, no ring expansion. No ring expansion because it is stabilized by dancing resonance. Stabilized by dancing resonance. Now, if there is 4-membered ring and the charge is on the ring, once again I will say no ring expansion, but ring contraction will take place. Ring contraction will take place and it will convert into this ring, but not fully. But not fully. Why? In equilibrium, this will remain as 51% and that will remain as 47%. Now you must be thinking where rest of the percentage would have gone. So how much is the difference? 51, 47, what is left? 2%. 2% will be alkene. 2% will be alkene. So remember that 4-membered ring will convert into this by ring contraction. This is ring contraction. It is converting into this by ring contraction. Ring contraction is stabilized by dancing resonance. There is no dancing resonance. So first of all, we should know these 3 points. First of all, do let me know if these 3 points are clear, then only I will move ahead. The first point, this one. The second point, this one, kids. This is your second point. If these points are clear, then only I will deal with rest of the things. Do let me know, kids. These 3 points are clear to each and every one. What I want to see in the chat section, is it clear or not, my dear students? Hey, everyone, are you feeling sleepy or it's okay? Are you awake? Tropylium carbocation will remain like that. That is aromatic. In aromatic, no shifting will be there. No shifting will be there in aromatic. Okay. Now, these are clear. Now, let me tell you how the ring expansion will take place. So remember that 4-membered ring will try to convert into 5-membered ring, will try to convert into 6-membered ring. So generally, the stability of ring is 6-membered ring is more stable. 6-membered ring is more stable than 5-membered ring. So stability of rings is like this. 6-membered, then 5-membered, and then 7-membered, right? Now, if I say that I am being provided with 5-membered ring, now this 5-membered ring and the charge is on this carbon, whatever the rest of the things are there, this will try to convert into 6-membered. So how it will convert into 6-membered, just see. This bond will break. This lower carbon will take electron, it will develop negative charge, and this will develop partial positive charge. Now see the condition. Now it will look like this. Negative charge, positive charge, and positive charge. The bond has been broken from here right now. The bond has been broken from here. This bond has been broken right now. And it has got chance to form a bond with that carbon. So remember that is breaking of bond. Here it is being breaking of bond, Bob, breaking of bond, and simultaneously there is making of bond, and both the two things will take place simultaneously. So partial positive, partial positive, partial negative. Electron triangle. From one side, breaking of bond is taking place, and another side, making of bond is getting formed, right? Breaking of bond and making of bond. If you are able to understand this much, that means everything got clear. Now you can clearly understand that from one side, the bond has been broken, and another side, bond has been formed, newly formed bond, and this is plus charge, and rest of the things are like this. This is 6-membered ring. You can write it like that, or you can draw it like this. Doesn't make any difference. Both are being same thing. Can you see, kids? 1, 2, 3, 4, 5, 6. Either this or this. Just see to it. If you're not able to understand, I will tell you number of times. Number of times I will tell you, but just to let me know if it is clear. I want to see clarity with the green hearts or green signal, green leaves, whatever you want to show that. But speedily do let me know. Then I can help you out, kids. Everyone, speedily just to let me know that you are able to get it or not. Fast, fast, kids. Speedily do let me know. Ring expansion is clear. Now, see, by chance, the question is coming like this. See, kids. So, if the question has been given like this, What will be the major answer? This is the question, kids. Now see, your first step will be that it is polar protic solvent. What it is? Polar protic solvent. What it is, kids? Polar protic solvent. And it is weak base. So can't do the reaction in single step. What it will do? It will slowly take away this chloride by solvolysis. So first step is always solvolysis. Solvolysis. Everyone says solvolysis. So this chloride will go away along with the electrons, and this carbon will develop positive charge. It is slowest step, and slowest step are always what? Slowest step is always RDS, rate determining step. In this rate determining step, what you will get, kids? You will see it's like CH2 and CH positive. Now let me remove this carbon, otherwise it will become lengthy. This is not for NEET. That is good for IIT but not for NEET. So I have removed one bond, kids. You can make it direct, okay? I have removed one bond. Can you do that if you're writing simultaneously? One CH2 I have removed. Sodium ethanoate is a strong base. Why? Because in sodium ethanoate, sodium is forming ionic bond and oxygen as having complete negative charge. But here, this is having partial negative charge because hydrogen is forming a polar covalent bond, so partial negative and partial positive. But in sodium ethanoate or sodium any alkanoate, that is ionic bond and that is having complete negative charge, so that is a strong base. Now this has been removed, so I would like to say, so it is having CH plus and CH3. Now once the carbocation has been formed, now you always think about rearrangement, ring expansion. So this bond will break, this bond will break, and simultaneously it will start forming a bond over here. So the situation will be like this. This bond has broken down and new bond has been formed, plus charge, and there is CH3. Now if I say this is X carbocation, this is Y carbocation, let me write down properly. I can write it like this also. The Y carbocation can be written like this also. Absolutely correct, no difference. Now this ring is of 6 carbon, but one more possibility is there, that this hydride can shift, then it will become even more stable. This was the ring expansion. First thing what has happened, ring expansion has taken place. Second thing, 1 2 hydride shift also will take place to give you the most stable carbocation. That means this carbocation is the most stable carbocation. Am I right? If that is X, this is Y, then this will be your Z carbocation, kids. Am I right? This will be Z and this is being most stable. Now from most stable, what you are supposed, always where there is plus charge, remove proton from the adjacent. If I remove proton from here, this place or this place, these two are same and this is different. So I will get two types of products. One product will be like this, CH3, and another product will be like this, CH2. The double bond which is going away from the cycle, exocyclic, and the double bond which is inside the cycle, endocyclic. This is endocyclic and that is exocyclic. Now if you see clearly, you will get that this is more substituted alkene, more stable. So this is your ZJ product, and ZJ is always major. I hope you got it. If you really got it, kids, all the alkenes, they will form a bond. All the alkenes, they will form alkene. But major alkene will be formed by that carbocation which is being more stable. More stable carbocation, more formed and more responsible for product formation. I hope that everyone got it. Kids, do let me know if everyone got it. Now, 5 minutes dehalogenation will take and 15 minutes, 15 minutes dehydration will take. Are you ready? The most of the important thing, toughest thing I taught you kids, 5 minutes dehalogenation will take place and 15 minutes dehydration will take place. Then alkene preparation will be done and dusted. That means 70 to 80% work has been completed. Only 30% work will remain. For that, I will take one more lecture based on hydrocarbon. Chapter will not get completed. Fifth means 70 to 80% chapter will get completed, right? After 20 minutes, 70 to 80% chapter will get completed. But to complete the chemical reactions of alkene and alkyne, I have to take second part of hydrocarbon because it's lengthy, right? Now, next is dehalogenation. Are you ready for this, kids? Now, dehalogenation is very simple, kids. Dehalogenation will not take too much time. Why? Because it's very simple. Dehalogenation, I have told you, loss of X2. Now, loss of X2, if I talk about NCRT corner, then CH2Br, CH2Br, right? 2Br. But for this, if I go, then let me treat it with zinc. Zinc and heat. Zinc dust and heat will form CH2 double bond CH2 plus ZnBr2. This will be your answer, my dear students. Now, this was vicinal. If this would have been geminal, then it would have reacted in this way. CHBr, Br, like Wurtz reaction. Its mechanism will be somewhat like Wurtz reaction, Br, Br. Now 2 moles of Zn, they will go. It will eliminate out in this way, kids. So you will get CH3, CH double bond CH, CH3. In Wurtz reaction, you were getting alkane, symmetrical alkane. Here, you will get symmetrical alkene. What you will get, kids? Symmetrical alkene will be the product plus twice of ZnBr2. I hope you got it. It's like this is geminal. This is geminal halide. And the thing is like Wurtz reaction. That's it. Dehalogenation, nothing to worry about dehalogenation. It's very simple. But if tough question has been asked, if they are going to ask tough question, then it will be a problem. Yeah, so see, Dr. R.R. Anish, he's asking whether it will be cis or trans. So see kids, here it's nothing. Here they will not ask cis or trans because both that depends on the stability. But where they will ask, see kids, the tough question. They will ask tough question over here. Suppose it's given like this, CH3, CHBr, CHBr, CH3. And now they are reacting with the zinc and heat. Now what will be the product? Cis alkene will be the product or trans alkene will be the product? That is important. Now see, remember one thing which I am going to tell you. If you want to see the mechanism, that also I will let you know. But right now, remember that if this is being meso and this elimination is always E2 anti, E2 anti. So meso, anti-elimination, then always trans. And second thing is that if it is racemic, anti-elimination cis. What are the meaning of these sentences? M stands for meso, compound is having plane of symmetry along with chiral carbon. A stands for anti, and T stands for trans. R stands for racemic, A stands for anti, C stands for cis. Now, this is having two chiral carbons. Now see the stereochemistry of this. If I draw this compound like this, now if you are able to understand, then see this compound is having plane of symmetry. Where is the plane of symmetry? If you see, if I divide this compound from here through one knife, so this will divide the whole compound in two equal parts. Can you see, kids? If I cut it from here, one plane is passing which is dividing this whole compound in two equal parts. The above half and the lower half is same. So although two chiral carbons are present, but this compound is meso, optically inactive. Meso, these two are chiral carbons. Now zinc will always do anti-elimination, always anti-elimination. So meso is undergoing anti-elimination, meso undergoing anti-elimination. So the product will always be trans. That is the answer. So the product will always be trans alkene. I hope you got it. One thing is this, I hope the stereochemistry is clear. Somebody was asking question that will be cis or trans. This is clear. Now there is plane of symmetry. Yes, plane of symmetry. So it is meso. Now if it would have been given like this, now see, this compound is optically active. How and why, kids? This compound is having chiral carbons but no plane of symmetry. So this is optically active. It will rotate the light in the same direction. The previous one, if you want to see, that was rotating in two directions. If I see Br with this is moving clockwise, then that was moving Br2, this anti-clockwise. But here the rotation is in same direction. This is clockwise and this one is clockwise. So same direction. I don't know, because whether it is dextro or levo, that will be decided by the spectrophotometer, and for that compound should be there. Just I am doing this with RR. I can say there are RR configuration. That only I can decide. If I say, if we take this to be dextro, this to be dextro, then my dear students, its mirror image will be, if you understand anything, mirror image will be what? Mirror image will be levo. Mirror image will be levo. Then the mixture of dextro and levo, we will say they are racemic mixture. What we will say, kids? Racemic mixture. We will say it is a racemic mixture. So R And zinc is always going to deal with zinc and heat. We will say anti-elimination. So what trick I have told you, kids? What trick I have told you, kids? Do let me know. That RAC. So your alkene will be definitely cis. I hope you got it. Everyone, you are able to understand. Just to let me know, kids. Show me green hearts if it is clear to everyone. Everyone, just to let me know, kids, if it is clear. If it is clear to each and every one of you, kids. Now, dehydration will take 5 to 10 minutes. Okay, let me tell you dehydration. Then at least preparation will get completed. Okay, my dear students. Dehydration means loss of water. Dehydration means, this is the third one. Dehydration means loss of water, and this will follow two mechanisms. Let's see what are these two mechanisms. First one is E2, second one is E1. Now, my dear students, the reagent for E2 will be, alumina, Al2O3 heat. This is known as alumina. Or they can use thorium oxide, THO2 heat. Here it is single step reaction. Single step reaction, and single step reaction, no intermediate will get formed. This thing I have already told you. Now for E1, it's acidic reagent will be used. What are these acidic reagent? Like concentrated H2SO4 or P2O5 aqueous, that definitely will give you concentrated H3PO4. So they will move with carbocation formation. So rate of reaction directly proportional to stability of carbocation. Stability of carbocation. How the carbocation will form, that I will let you know. These are the two things. Even multi-step, that is complex reaction. There also I've told you this is complex reaction, so multi-step reaction. And this is elementary reaction, so single step reaction. Kids, are you getting my point what I'm telling you? This is elementary, so single step, that is complex, so multi-step. Let me tell you even reaction, that is very, very important. See kids, if somebody has given you question like this, most important, concentrated H2SO4. Now don't believe on anyone, kids. Just ask to yourself, out of these two things, who will do the initiation of the reaction? The answer lies concentrated H2SO4 will give H plus. It will throw out this H plus, that is proton, and proton is searching for lone pair, so this proton will attack on the lone pair of oxygen. Am I right, kids? Am I making sense? So this proton is going to attack on the lone pair. What you will get, kids? Definitely you will get CH2O positive H2. This is known as oxonium ion. If the charge is on carbon plus charge, carbonium ion. If plus charge is in oxygen, we will say oxonium ion. Very good, rising. Very good. Oxonium ion. We will say this is what? Oxonium. Oxonium ion. Now this oxygen will say, I can't bear out this positive charge. I can't tolerate this positive charge. So water will eliminate out. Once the water has gone, kids, once the water has gone, you will get plus charge on that carbon. Now whenever carbocation is formed, think about what, kids? Whenever the carbocation is formed, always think about rearrangement. So ring expansion will take place. Am I right? Ring expansion will definitely take place. And ring expansion will give you more stable six-membered ring. So wherever plus charge is there, just eliminate out proton. These two are same. So whether you remove proton from here or you remove proton from there, so negative and positive, they will form a bond. So this is the major product, major alkene you will get, kids. I hope that you are able to get it. Now if by chance somebody is asking, write down all the products, what all type of products, all type of alkene you will get. So let me tell you rest of other products on next slide. Just see, you took this one, first carbocation formed was this one. So it's next only one hydrogen from here it can go. Here it can go. So positive and negative, one alkene will be this one minor, but yes, this one will get formed. Now from the same carbocation, one thing could have taken place without ring expansion. If hydride shift, there are n moles, n molecules, crore molecules, lakh molecules, number of things possible, that in some molecules without ring expansion, if hydride shift is taking place, this is going to this, then you would have got this carbocation, and in this carbocation two possibilities are there. If it is going from here, here same, and if it is going from here, that already we have made. So one, this product formation, and another one endocyclic, this one is also minor, but definitely it will get formed. Third thing, ring expansion has taken place and you got this one as the major one. So out of these three types of products, this one is major. I hope that everyone would have got it. Everyone is able to understand it. Now, why I taught you even first, so that easily you can understand E2. Let me tell you E2 and even with one simple compound so that you can compare easily. Just see the comparison. The comparison you can do, comparison. If I provide you with neopentyl alcohol, just see. And if I put Al2O3 over here, that is alumina, and heat. Now see where oxygen is attached, that is alpha, and this is beta. No beta hydrogen, so no reaction. No beta hydrogen, so no reaction. Now kids, can't it form oxonium ion? No, it cannot form oxonium ion because there is no proton. No proton. So no oxonium ion formation. Are you getting my point? Now, at the same time, if it would have reacted with concentrated H2SO4 heat, then H plus would have reacted on this now oxygen got positively charged because of oxonium ion formation, then water would have eliminated out, then you would have got what? Carbocation. And once the carbocation is formed, always think about rearrangement. Then 1,2 methyl shift would have taken place. Then you must have got CH3 plus CH3. Now there are two chances that either you can eliminate proton from here or from here. So two possibilities we will explore. One product we will get like this, CH3 double bond CH3, and another one CH2 double bond CH3 CH2. Now which one will be major and which one will be minor? Only 1 second, kids. This is ZGF more substituted, so ZGF will be major here, always major in even reaction, always major, and Hoffman will be minor, less substituted. Now preparation of alkene is done and dusted. This is all for today, kids. Thank you for giving this much of your valuable time and giving correct answers. How you're feeling now, kids? Do let me know. That I haven't skipped even a single thing. Just to complete the whole chapter, I would have completed. Kids. But just leaving few things, I am not having that habit. Yeah. Krishna, you can ask whatever you want to know. Thank you, Hames, thank you. I always move with each and everything in detail. Rising Star, very good answers given by you and number of other students also. Kumudha, very dedication level is very high. Rising, Kumudha, rest of other students. Now, my dear students, I have not left even a single thing which I haven't told you. Are you? I don't know. Krishna, this I don't know. I just, whatever I get, I eat. I don't know what is this. Okay, kids. So do only one thing, just do proper revision, and I will come with second lecture of hydrocarbon. There I will complete the chemical properties of alkene and alkyne. Only a small portion will be required. Doc DR2, we thank you. Lalita, thank you. Oh, morning is there. Good morning, Darshan, Minod. Good morning. Very good morning. So, kids, will you do proper revision? And how was this lecture? Will you write down in the comments once this video is over? I would like to see your comments afterwards. Right, kids? So, bye to all of you. God bless you. Love you, kids. May Almighty God bless you with all happiness and prosperity. Good night, good morning. Bye to all of you. God bless you. Love you, kids.